Okay. I was not kind of ready at all to hit the the stream button. I kind of just did it automatically. It just kind of took over. I don't even have music. Okay, I do have music. I have no clue if I got the audio set up correctly. I didn't even like test it, so that's my bad. Um, I think it looks good to my eyes. I usually just do like a double triple check on it. Um, so I had a breakthrough last night, where I was like sitting here very annoyed at the fact that I spent so long on this and worked so hard and it just didn't look good, even though the math works and I implemented everything correctly. And so, as you know, yesterday you could probably tell that I was in kind of a bad mood about it. Um, However, I I completely uh, I was like, okay, well, let's take another look at the rendering. And then I just was like, okay, let's just do the face normals on the vertices and not even worry about averaging nothing, the overhead. And I just did the face normals on the vertices, and automatically everything looks like insanely good. Uh, so there's that. It wasn't like one of these things where I was like, banging my head against the wall. I just like kind of gave up, and I was like, okay, what do I do now? And I just straight up just put the face normals in the vertices, and now it looks amazing. Which you can probably tell. The mic is kind of, I banged it last night. So I did put a little bit in the Discord about it, just to show it off. But as you can tell, it looks a lot better, and I'm really happy with it. To talk about what I did last night, I stayed up till like 2 a.m. Taking some code from my 2D Linea implementation and trying to implement it in the 3D. I don't know how successful I was. But I did try. Hey, what's up, parents? Long time no see. Good to see you. Um, well, thank you for coming to say hi. Hi to you too. How are things with you? Yo, what's up, Arya? Um, yeah, so we still have these weird things. So because our grid is so small and because our kernels are so big, we end up sometimes getting these patterns, as you can see with the red here, where we get these kind of wall patterns that happen in these lines, as you can see, which is pretty strange. But they do appear on certain layers, right? So if I had to guess, I think the red kernel is just too wide, the radius. Oh yeah, thanks. Yeah, it is awesome. So I have this R button that basically it finds the radius of the first kernel, takes it as a neighborhood, and then does a 3D kind of noise around the center. Yeah, I do still remember you. I remember pretty much every name. So that's what the R is doing. And so I spammed the R so much last night trying to find any sort of movement. Do I not have enough resources? So it's a part of it being on Windows XP, but it's also, I can make it more efficient. It's also the problem that I'm using a pre-compiled binary for the FFTs, for FFTW, because it's incredibly hard to compile it yourself for, Visual Studio 2008. I think I may have to, though, if I want to scale this. So right now, I'm fairly sure that FFTW is not multi-threaded, which, if it was multi-threaded, it would probably be around 2 times as fast, which would be a huge game changer for us. Now, that's not to say, right now we're at 32 by 32 by 32. My goal is to eventually get to at least I want 64. But we got to temper our expectations because my 2D implementation capped out at 100 by 100 once I got to flow linear with like all the mass reintegration and Sobel convolution and all that stuff. So yeah, it's never going to be like an entire world. The math that's going on here is incredibly complex. Not to like be like, oh, it's so crazy complex, but it is kind of the amount of convolution that goes on. So anyway, so sorry, can I get some content? What are you trying to do? It looks cool AF, but the thing is, what the hell is happening? Okay, so let's try to, because I know people always ask like, what am I doing? And I say I'm making a 3D implementation of a 2D cellular automata linear, and then I give them the link, but it's like, okay, but what the fuck does that mean, right? I'm not going to read a whole paper on it right now. So if I can start from the top, right? We have a 3D volume of 32 by 32 by 32 in terms of like, we can think of them as voxel cubes, right? Inside of them, we have just a floating point value between 0 and 1. It's very simple, right? Now, if I create the field from scratch, it just does a bunch of random stuff. But right now, I'm creating circles around a kernel. Now, so what is a kernel? I'm not talking about the Linux kernel here. If you know anything about image manipulation, Gaussian blurs, anything like that, you'll know that Gaussian blur uses a kernel, which is just a circle. I mean, it's really a square around a pixel, right? And it's a square of weights that it looks at the neighboring pixels and sums them together and divides them to find the weighted average for the middle, right? And that's how a Gaussian blur operates. So just imagine this, but way more complex, right? Instead of having a square kernel, we have a circular kernel with what we call betas, which are rings inside of the kernel, right? So those individual rings at different widths inside of the kernel have their own weights, right? It's really hard for me to show and visualize it. I should make a visualization later, but I did on my 2D. But anyway, you can think of it as like, an onion with layers. Okay, so that's what's happening, and we have that in 3D. So it's basically a 3D sphere that we are pushing through that 3D volume and summing up and dividing, and it's called convolution, right? Now, doing actual convolution would be way too slow. So instead what we do is FFTs. So what is FFTs? FFTs is fast Fourier transform. Now, how do FFTs help us here? Isn't it used for like frequency for? Well, what we end up doing, there's this formula. I forget what it's called. It's some sort of property of FFT with complex multiplication, where we can multiply two complex numbers, take the reverse FFT, and then we convolve it, right? So basically, what we do is we take our kernel, we do a forward FFT on the kernel. We take the entire cell grid, we do a forward FFT on the cell grid, and then we complex multiply them together, and then take the reverse FFT, and that gives us that weighted neighbor sums that we were just talking about. And then we put it through a growth function, and that's basically it. I wonder how fast and large the same would get on modern GPU with compute shaders. I don't know, really. To be honest, like, all of this has to be done on the CPU. Because of the FFT stuff, the library is kind of on the CPU. So I think you're kind of bottlenecked by that, to be honest. Like, it's not really the graphics that's the bottleneck. Anyway, I'll try to explain it as good as possible, but maybe it wasn't as good as necessary. Anyway. So, I had some ideas. First of all, what I want to do is I want to get per vertex color that's actually per vertex color and not actually just the face vertices. And so the simplest way to do this is to straight up just not write into the vertex buffer right away. And instead just defer it until after. And have a buffer of normals that we are summing into, that we then normalize at the end. Yeah. So we get this normal, right? And so this is the normal, and so we have to push this onto each point. Each point's. Yeah, maybe this is going to be more complicated than I thought. Yeah, so I guess we could have an array of these 3 points, right? And then just look it up later. I'm just worried about like rounding issues, to be honest. So yeah, the P's are rounded. This is rounding it. So we might be safe if the points are rounded, but then we have this interpolating logic, so I might have to round it again, which is non-trivial. Okay. Alright, so let's do that then. So at each of these points, we need to place in this normal and add it onto each of these points. Yeah. Yeah. Okay, so let's do that then. So how big would we need this to be? We're going to need it to be... I wonder if I can actually use GZ, GX, GY, and GZ for this. No, I can't, because the points are not per that. The points are for all of these corners of the cube. Oh, sorry, I don't have music on because I don't have my headphones on. I hope that's not too loud. Yeah, that is pretty loud, I'm sorry. Okay. What is CA dev? It's cellular automata. Yeah, so if I want to get this per... Yeah. First next vertex. Okay, so we have to make a function that then gets the index into whatever table I'm going to create now. And I think I have to create a table with the same bounds probably as this. Yeah. Yeah, so grid width divided by max threads times cell size. Okay. Okay, so let's just for the proof of concept right now, let's just calc it. It's gonna be, yeah, let's just do vec3 normals. Yesterday comments were off, was it? That was not my doing. I'm sorry about that. I don't know why that is the case. But yeah, that was not my doing for sure. I don't even know if we're going by cell size. Yeah, we are going by cell size because this YZ is getting iterated by cell size. Yeah. So it has to be by cell size. So it's this, and this times cell size. 100%. Yeah. Okay, so then let's just, once again doing it quick and dirty, what I want to do here. Let me think about this. Can I do... I can't do this. That's not legal. I have to actually do this. I think so. There is a much better way to do this, but I'm not worrying about it right now. I just want to make sure that this is possible. Okay. Okay, so that's that. And then at the end, we just free our normals. Oh, this is actually per channel. Walter, please get back to the lab. Is that me? Am I Walter White? I love Breaking Bad. It's such an amazing show. I know, like, it may be like, you may think like it's overrated or something like that, but no, it's like such a brilliant show. I think my parents thought that it was like overrated when it came out or whatever, and they didn't let me like see it because it like dealt with drugs or whatever. But it's like such a brilliant show, and I have, you know, I have a bias because I've been I've been compared to Jesse Pinkman a lot in my life. Yo, what's up, Def Colony? Okay, so we have the normals. Now we need to, if I'm thinking about this correctly, these need to be rounded. So I have this thing called round vec3, I think, that's already a thing. So I can do a round vec. Yeah, I already made this. And then that will give us the index into the table. I'm just gonna make a function that does that instead of doing a macro. I know that all the macro kids love the macro kids, but sorry. Wait, hold on a second. Yeah. CI dev is cellular automata dev. Some graphics dev. I do the chess engine. Yeah, I did the chess engine. Yeah, thanks. Yo, what's up, Empathy Monster? I remember you. Hope you're doing well. Yeah. So this is just gonna be an int. We don't have size t. So this is basically just a macro. What I'm going to do here. Yeah, so this is, it is cell size, isn't it? Yeah. Yeah, it has to be cell size. Yeah, I mean, this looks bad, but am I developing on a physical machine? Yeah. This has Windows XP on it. Yeah. I have a capture card. I bought a capture card for it so that I could stream it. First signs of life. Yeah. I do have the life. Sorry, I just got stuck in my brain for a second. I do have. I think this also needs. No, we already have cell size inside of here, inside of the A and Y. Okay, let's try to do this without cell size first, and then let's just allocate it without cell size. Sorry, I'm a bit scatterbrained right now. Am I making a game? It's more like a simulation, yeah. We can actually allocate it to this much. We're just not going to use all of it. Yeah, so I did a lot of work on it last night, is what I was showing off earlier, but maybe people weren't here yet. Let me just show that off once I deal with whatever this is. Yeah, it's some warning, whatever. Yeah. Where's the error? It's here. Oh. Yeah, I really hate how you have to cast the pointers. It's so annoying. That keyboard is not the one that I'm using right now, by the way. Why is this... Wait, what? Oh, my bad. I'm so scatterbrained. Okay, so this is what I was trying to show off. Is that, so I did a lot of work on it last night visually, and now I'm trying to average the normals properly, but this is what it looks like right now. You do kind of have to just press the random button until you get some actual formations and some movement. It is kind of hard. It's harder in 3D than it is in 2D to find interesting things going on. You get a lot of this, but you can definitely play with the parameters yourself and try and see what goes on, really. Yeah, it's hard for it to not die, of course. What is vec3 pointer x? What do you mean? Where did I put that? That's a multiplication sign. Okay. So that we should be able to index into it now, hopefully. So we want to place. Okay, so hold on. So we're gonna put this down here after we get the normal, and then we want to index into it. So normals index by the normal index of that, and we want to yeah, we want to vec3 add. So let me, I don't even think I have a vec3 add right now. I do have a vec3 add. Okay, so this is not going to look the most pretty ever thing, but yeah. Oh, the chat is going off today. Oh, but a simulation of what? It's a simulation of cellular life. It is procedurally, it's all generated with math. Well, not like, you know, procedurally in terms of like a network or anything, it's just math. YouTube recommended this stream. Hey, what's up? So Conway's but 3D. Yeah, it's similar. It's called Lenia. Is the name for it. So this is going to be, we're just adding n to the existing vec3 at this position. Okay, so this is, it looks really disgusting, but you're disgusting. We're just slotting it in at every single place. Your eyes are burning? Yeah, I'm sorry. I think light mode is cool, sorry. Lenia, yeah. I can show you, I can give you the link. It's by this guy called Bert Chan. This mathematician. Okay. I made a 2D implementation, but I was like, why hasn't anybody done it in 3D? So, okay. So now all we have to do oh, this is actually tough. Hold on. Because we're omitting the vertices, and now we need to know what maps into here. You know what I don't want to do? I don't want to step back through the array. I don't want to step back through the array and then like have to reverse engineer from P0 this normal index again. I do not want to do that. That sounds like a really bad idea, actually. That sounds like super inefficient. 6502. Yeah, that might be tough. Oh, this looks old. Yeah, it is old. It's a 2004 to 2008 era. Stuff going on. Yeah. What's the most efficient way to do this is the question. What would be kind of cursed? It is possible. I mean, it is kind of cursed. We could have an array of these indices for each of these. Yeah. But that's a big array. That's a lot of malloc. I mean, I could just keep the array around though. But yeah, so what I'm thinking right now is we have an array of these indices that map to here. So that when we loop through these vertices again on the GPU to find the to slot the normals in, we know where to look in the normals array. If that makes sense. Yeah. Yeah, I think that's it. I thought you had way more subscribers. Yo. Yeah, thanks for stopping by. Yeah, I think that's what I'm gonna do. I'm not gonna lie, it isn't going to be pretty though, but I think that's what we have to do. I'm just going to... We're gonna keep the array around. I'm not gonna malloc this every frame, but for now, I am going to, just for simplicity's sake. So, yeah. What's a calloc? It zeroes the memory. Yeah, so this actually is going to be, like I said, this is a much bigger array because this also has to go for each vertex, right? So this is times 36. Yeah. So it's safer than using malloc? It's not necessarily about safer, it's just if you need the memory to be zeroed, then use calloc, right? You know, like if you're going to be looping through an array, for example, and filling it with memory regardless, then you can just use malloc and it's fine. Basically what happens when you allocate memory or when you try to get memory, you're getting memory that was already dirty. Do you know what I mean? It's not like you just get memory that's already clean, right? So when a computer says, you know, you malloc something, you're just grabbing memory that may have already had data in it, you know? I watch anime, random question. I have watched anime. I'm not not actively though. I like older anime. I like Ergo Proxy. I think Utena is also sick. I think Evangelion is kind of cool. But past that, I'm not insanely into it. Okay, so every time we do this, right, we need to put into NIDX. Yeah. Yeah, so let's do this here, just so that it makes more sense. So NIDX indexed by the VIDX, which is the vertex index, will equal this normal index that we got here. So, So this, okay. It's probably a more efficient way of doing this, but I'm too kind of dumb to figure it out. Okay. Okay. So we need to keep this pattern going for all of these, and then, yeah. The reason why I'm doing this here is because I need to map it. Okay. Hi, new day, new bugs. Yeah, you're telling me. Hopefully no new bugs. Hopefully. Okay. Okay, so that's all of the indices, and now we're going to use these indices. These will be what we slot into here. So now, when we loop through this vertex array and try to get the normals, we know where we're going. Probably miss those helix keybinds. I do. But I also like, you know, entrenching myself in this sort of, society sucks, so I do new things. So, here we go. Okay, so we have this slotted in. Okay, now what do we do with it? At the end, we should have to loop through. By the way, we also shouldn't be putting the normal in this constructor, but it doesn't matter right now. We'll just override it. So there's two things we need to do. We need to normalize all of the normals, and then we have to loop through all of the vertices and then assign them. So yeah. Okay, so then we just do that. So okay, so yeah, so we need to normalize all of the normals. So it's especially good in this 0, 1, 2 case. Yeah. Okay. Yeah. Yeah. Yeah, so we need to go through, yeah, so this is gonna be, yeah. Yeah, I'm sorry, man, I'm not gonna do a macro like that. I appreciate the advice, but I'm not going to do that. I'm not going to do that. It's really not that serious, man. I'm telling you right now, if I have to save 3 lines of code by writing a macro to do 3 lines of code, I'm not doing that. I'm not doing that. I'm sorry to disappoint you, but that's not happening. Okay. I need to assign these normals now to this, right? So TDB. Yo, what's up, Saz? How are you? Okay, so I'm just straight up going to do this. Normals by using this index to go into the nidxi dot x. Yeah, so then we're just assigning like this to the points afterwards. Okay, I have no clue what I'm doing. Yeah, I have no clue if this is gonna work, but I mean, there's a chance it just works. Okay, I mean, we should just give it a shot, I guess. Okay, let's see. So, yeah, why is this a problem? Oh, that's this. Okay. I don't think that it worked. I have a strange feeling that I don't think that it worked. Okay. Well, maybe my idea was a bit hasty. Yeah, maybe doing this normal index thing isn't correct. I don't know. We'd also just straight up use the cell index for this. The grid index for each point. Let me try getting rid of this dotting thing that I'm doing. Maybe that has something to do with it. No, I don't think so. And I do zero the array, so adding is not it's not the issue. Maybe rounding is not the best way to go about it. The idea is sound, the implementation is not. I'm just making sure that I didn't do something dumb here. And that it's, you know, the problem itself, not the... Yeah. Maybe we do have to go by cell size. The problem is that that's not an integer space anymore. It's kind of the problem. But this is not kind of fine enough, to be honest. Like, we're basically rounding it to... Yeah. Yeah, I mean, we could do it, but like, I've been sitting on implementing a global descriptor table for 2 days and I finally did it. Awesome. I have no clue what that means. That sounds cool. That's way above my pay grade. How would you do this shit? Like, maybe this is like something where like a hashing thing makes sense, but you know. I wouldn't because I don't know graphics programming. Got it. So basically what I'm trying to do right now is that I have these points, right? And I need to average the normals for all of the triangles that are next to the points, right? And so basically I emit the triangles, right? And I'm trying to basically accumulate into each point. The issue is I kind of can't map back out which vertex matches to which point because multiple vertices probably share the same point, right? So it's kind of yeah. I wonder if that's possible though. Like, can we just like, can I just hash this? Like, if I have a hash table of like times 36, right? Because that's the max amount of vertices, and then we actually just like straight up instead of doing this, like we just like hash it like this. Is that I certainly don't know. You're on your own. That's alright. I'm always on my own. Yo, what's up, Shari? This is what it's all about. This is what graphics programming is all about. Is that doable? The thing is, since okay, so a few things here. We would have to not round them, but they're already round. Okay, so let's not round them. Let's not round them. Let's not round them. Instead, what we can do is we can multiply them times 36 and then cast to int. Maybe I'm making this way too fucking complicated. Hold on. hold on. I think I'm like cooked in the head. Oh, today is Valentine's Day? I didn't even know. Right. Yeah, I knew that. So I think that's what I'm gonna do. I'm gonna... Yesterday before going to sleep, I forgot to wish me. That's alright. I mean, I always have a great Valentine's Day. You know me. I think Valentine's Day is kind of full of shit, to be honest. Okay, well this is certainly interesting. Yo, what's up, Rexon? Okay, this is certainly interesting. On Valentine's Day, single people feel alone like they aren't alone on other days. Why complain? It's also like, I just think that the holiday is kind of full of shit, like in general, though. I don't know. Like, if you're in a relationship, why do you need to, like, celebrate it? Isn't every day like Valentine's Day? I don't know. Like, what? Like, what's the special, like, oh, yeah, I love my partner because it's Valentine's Day. Like, as if that's, like, not any other day. I never got the fucking thing, to be honest. I never got the whole deal. I mean, most holidays are full of shit. Yeah, like St. Patrick's Day is also full of shit. Dude, how am I supposed to do this? Hash vertices and average normals. How do I do this? I am hashing it correctly now. Search the history is pretty interesting. Yeah, it's like a Saint Valentine, bro. I know, I went to Catholic school. Don't ask. Do not ask me. Hold on, my brain just expanded, by the way. Hold on. This is actually times... Okay, I'm starting to think that I have no clue what the fuck I'm doing. Receives this misspelled right times. It's funny. Yeah, I have a feeling that I'm not doing this correctly. Okay, so hold on. Technically, you know that Romeo and Juliet was never, yeah. Yeah, man, I read Shakespeare, bro. I know all about that shit. Okay, so we got 8 corners on a cube. We're just gonna iterate 8 corners on a cube. Right? Because we only got 8 points at max. Wait, but we don't. We don't. We have 12 vertices possible. We have 12 vertices possible. I think it goes up to 15, actually. I think it goes up to 15. Um. Yeah, I mean, we just loop through the whole thing again, and then yeah, but then oh my god, this is so stupid. Uh, okay, I'm giving up on the hashing thing. I'm giving up on the hashing thing officially. I'm giving up on the hashing thing. I'm not doing that. I'm not doing that. It's not working. It's not working. Instead, what I will do is that we're just going to multiply by like 100. Yeah. This is Windows XP, yeah. We're just gonna multiply times 100 and then just have a huge fucking table. That's what I think. That's what I think. Wait, don't you have to do... Isn't it that, though? I think it's that. Yeah. Yeah, that's a huge fucking table, man. That's a huge table. Hold on. Okay, what's the problem? Yeah. I'm all over it, man. Oh, fuck. I am stupid. Never mind. Yeah, that's fine. Okay, we got a fatal error. Dude, I thought that this was not going to be this hard. Hold on. Did we go out of bounds here? Okay, it's not going to tell me. Oh. Maybe it isn't this. But yeah, maybe it's just that. What about the security aspect? I don't have the internet on this computer. Bro, the normals, man. The normals. And Vec3 add is correct, right? Yeah, that's completely normal. Maybe the normalize isn't enough. Has my computer been hacked before? No. This... What? Wait, what? Wait, what? How is it not getting any normals, though? Wait, what? Because of the time difference, if it's you getting there? Yeah, I'm getting there. It looks good right now. I'm just trying to average the normals and find a way to, like, basically hash it, hash each point's position. But nothing is getting through. I'd love to know what the... I'd love to know what these... What the... What the fuck? Okay, that's an insanely large number. That was like 1 billion. Okay, so maybe like times 5? Stream 5 like I'm seeing in early 2000 movies or web series. Yeah, that's definitely the goal. Okay, let me see. Let me breakpoint this here. Like... Like, why does... this not show up for me? NIDX is P1 is 1065.3. And what is P1? It's 1Y. What the fuck, man? One times 32 times 5. Can I not just cast it to int? When does my birthday come? It's actually in 4 days. Are those high power glasses? No, I just prefer glasses. I don't like the whole context thing. I like to sleep whenever I want to sleep. Does that make sense? I feel like these indices cannot be right. And so this is really annoying me. Maybe just don't cast the int. Is all it is to get wasted and work on my shit. Yeah. I used to have to work holidays. It's like fucking trash, dude. I wish that it told me what this is. Like, I can't... Do I have a programming job? No. I've never had a programming job. Obviously not, because I can't figure this shit out. Oh, it's on the 18th. We're going on a trip to no. I don't do anything for my birthday. I used to go like to the movies in New York or whatever. Giving too much credit to the LinkedIn Fang slop employees. Trust me, I'm not giving them any credit, but I was just making a joke. I really want a job that's like working at like with like just like doing some embedded programming for like machines or whatever. Like I used to work at like a shop with like CNC machines and shit, and like, you know, all that like cutting metal and stuff like that. That stuff was a lot of fun. I really miss doing that engineering stuff, but not like the engineering, but like the just making shit. Like that was a lot of fun. I kind of want to do like programming for those machines. Yo, what's up, Mano? I wonder like if I just do this in line. Tokyo Spliff has a graphics programming job he does twice a day. Yeah, he's pretty fortunate to have that. That does sound like the life, yeah. Why is this so cursed, man? Maybe kernel development and security, yeah. The problem with like jobs like that is it's like you have to actually like learn a skill that like you don't even want to do. Like kernel development and security. Yeah, that sounds like really fun shit. Dude, like I mean like I feel like I'm going crazy here. You know what I'm gonna do? We're just gonna actually straight up print out the NIDXs because I'm tired of fucking sitting here and looking at this shit. I always forget what the name of the function is. I'm just straight up going to... I wish you could do this inline. I don't think you can. You have to actually like... Can I please get the debug window, bro? Like... Bro, I'm so mad at this today. Oh my god. Just please. Just end me. Don't end that. End me. End me now. Don't send. Okay, so... all of these are actually legitimate indices. So, you know what I now think? I now think that, like, the fucking debugger is actually bullshit. The debugger is actually fully bullshit, bro. Because those values were not even bad. Like, it was telling me garbage. Oh, probably because I was in release mode. That might actually have to do with it. I'm stupid. Yeah, but this still doesn't work. Yeah, let's actually go into debug and then like let's actually just like look at the normals that are coming out. The issue is that there's so little actual normals that like that's just gonna be 0 0 0 0 0. I could of course just like check it if the normals is greater than 0, but whatever. How complex is the math? How old will I become? 25 or 26, I can't remember. How complex is the math? It's not complex, it's just stupid. $69. We don't have any loss of data. That's what I'm trying to prevent. So what I'm doing here is I'm basically just like multiplying it times 100 to try and get it from floating point into integer space, right? Because I'm trying to find an index into the table. That's what I'm trying to do. It isn't working though. It is not working. Hold on, let's actually just straight up let's actually straight up just like print out the normal here. The way this is going to help me figure out what's going on, because I'm actually just going to print out the I'm only going to print out if it's, you know, if it's greater than 0. Am I talking about robotics engineering? Yeah. But not like, it doesn't have to be like engineering. I'm just like, okay, so it hanging immediately has to probably means that we hit it for sure, so. Yeah. So we do have normals. And they're all in the correct range. They're all normalized. Fuck. So is that you in the video title? Yeah, that is me. VI and NIDXI should map back together. I don't even know how to debug this is the problem. Because like there's nothing that I can even log. Like what am I supposed to log? It's like there's nothing to log. It's just like nothing numbers. I guess what I could do is I could log like one specific vertex and then like see, it's like, how would I even, yeah. We track one specific vertex and then see what happens to it. Like, I really thought that this was going to work though. And I'm sure that this, yeah. Yeah. The NX, NY, and NZ is definitely the correct member. You know, I haven't really like considered the fact that maybe it's working and it just isn't good. I didn't really consider that. Which is probably something that I should have. Why'd I cut my hair? I didn't like it anymore. I just had a subby. Yeah. 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 For me, it was the opposite way, for sure. I loved programming, like, terminal applications from the beginning. And then once I got into, like, the real programming, which is, like, trying to fucking put an event handler on a button, I was like, okay, fuck this. Still trying to get long hairs. Yeah. Yeah, I got sick of people like calling me like John Lennon and shit. Yeah, I mean, maybe we put this on the back burner. I don't really know how to do this. And this is like so complicated. Really want to work on something. Yeah. Yeah. Hold on a second. Hold on a second. Hold on a second. Oh shit. NIDX. Oh shit. Oh. Okay. I just had to like think about it for a second. Hold on. This has to be per. This can't be per channel because NIDX is not per channel. Okay, and we get green now. Okay, there we go. Okay, so this is still fucked up, but that is okay. So that makes sense. That makes a lot of sense, actually. Now maybe I can go back to the. Oh, this is with the. This is with that. I had this here, but. The thing that's concerning is that I don't get red. Yeah, don't argue, guys. There's enough arguing with the guy that's trying to tell me how to macro for 3 lines of code, bro. Enough arguing. Yeah, I've seen people that have contributed to Linux kernel. It's pretty crazy. I wonder if I'm indexing this correctly. I might just switch back to the regular indexing just to see if this is, if we're okay. Would you have a question? Well, ask away. I'm sorry if I'm like coding bad today, or I'm just trying to figure this out. So I'm pretty confused on how to. Okay, so this almost is getting there. It is. Do you see the smooth kind of shading on it? The annoyance is kind of the black spots. Okay, so so I'm gonna like blow your brain here for a second. I think that actually this is correct. Multiplying would truncate the number, which would become 20. Yeah, exactly. That's what I'm trying to do. I'm trying to change. So, for example, I have an array, right? And it's not fine enough because I have points inside of between 0 and 1, right? So let's say we have a voxel grid of 32, right? What's happening is that I have points that are in between 0 and 1. So what I'm trying to do is I'm multiplying it times 100 so that it can get that 0.2 becomes 20. Yeah, exactly. That's what I'm trying to do. The thing is that isn't working, but also like bringing the precision down to here, I think this is working. I think it just looks worse because of the black spots and stuff. And the weirdness of like it slowly turns black, which is weird. I wonder if normalizing twice is bad. Technically, normalizing twice shouldn't be a problem. But I don't know. God, I'm gonna look so dumb back in the recording for this. I'm sorry. I'm sorry. Yeah, I wonder why the 100 isn't working. Like, in my mind, it makes sense. Maybe I should be multiplying the whole... No. No, you shouldn't be multiplying the whole thing by 100. You have to multiply the individual components. It's like, but how am I not going out of bounds? And I know it's laggy. It's just because I'm doing a lot of like allocating and stuff while I'm doing this, but yeah. Do I have to do that like this? Is this seriously the thing? Or is that doesn't seem right, though. This seems like we're just gonna go out of bounds. Yeah. I could try multiplying the whole thing by 100. I don't know. Yeah, just do the whole thing by 100 before the cast. What are you talking about? What? Oh. Yeah, that seems like the exact same as what we had previously. Alright, good night. Peace out. It's my kind of thinking that this might not even be wrong. I don't think that we can... Yeah. It's gotta stop doing this, man. It's so annoying. What are we supposed to see? We're supposed to see like clean normals for the lighting. Like smooth shading. Or are these not squares? What do you mean not squares? I can show you what it looks like without it, sure. Like, this is what it just looks like with the face normals on it, right? So it looks pretty normal, right? Of course, it's a bit laggy since we have all that allocation going on still, but yeah. That's what it looks like without it, but we want smoother shading than that. You see how there's like, you know, light sides of the triangles and the darker sides? So I'm trying to fix that, but it's not really working. I have a feeling that, to be honest, this might not even be possible. Mainly because I'm thinking this might not even be possible with this marching cubes technique, because we don't really have normals that go around, right? We just have kind of like, we end sometimes. We just like, we have like this, and then there's no face on the other side to average with it. Feels like 100 is too small. I don't think that more is going to help, and it's just going to fucking. I mean, I don't think that we need that level of precision, but I can show what 1000 would look like. Allocating that much is just absurd, for sure. Yeah. Yeah, maybe just multiply the whole thing by 1000, actually. I think that makes more sense. But God, it's annoying that this is... Why is this, why are we seg faulting? I don't know. I don't fucking know. I'm getting tired of this, to be honest. Dude, like... I think to be honest, I think that maybe Calic is failing. Yeah, that's exactly what's happening. Yeah, that's exactly what's happening. Calic is just failing because it's too big. So, there's that. Yeah, I think we just say fuck this. I think it's possible that it's just not. At least I can't figure it out right now. I've tried hashing it. I've tried a billion different things. It's not. I don't think it's going to work. Sorry. I came up with this idea earlier today. I was like, okay, I'm going to give it a shot. I'm going to hash the points. And no. And it's not working. So... yeah, let's not waste any more time on this before it like becomes a big fucking time sink and then we lose our minds, because it might just be like literally a problem with the, and you try to give triangles a backside shade, it doesn't really work like that. It doesn't work like that because you would have to also average in reverse normals, and then there wouldn't be shading at all. You can't really do that. You can only have normals for the outside, right? So if you go into Blender and then you try to like do normals or like, you know, make a model, and then you're only going to get normals on the outside. That's kind of the point, right? Hey, what's up, Tools? Good to see you. Thanks. I'm doing good. I'm doing good. I'm trying to do some normals stuff here today, but I don't think that it's going to work, really. That is what it is. Yeah, so let's just put this back to what it was. This was actually like backwards, which, you know, it, for whatever reason it works. I wish that this, oh yeah, and IDX we don't need anymore either. Okay, so let's just like give up on this and then just go do something else because I don't want to deal with it. Yeah, but I think so. What, like, going back to this, what I'm seeing here is that like you see these black lines in the black stuff, right? The algorithm itself inherently gives us these weird normals because we're getting geometry that is 2D in 3D space sometimes, right? So that's why it sometimes doesn't make sense, the normals. And so when we're averaging bad normals on top of each other, of course it's going to become like black. So I don't know. I think that as probably just like, you know, we should just like not worry about it too much. Whatever, man. Whatever, man. Okay, so next few optimizations I want to make. What else we can do today? So I did some research. I was like, okay, so this create thread thing every frame. This is how I do it in my chess engine, by the way. This is apparently pretty bad, and especially on old hardware, it can be pretty bad as well, like with old CPUs. And so what we should do is we should just initialize them once. Told you before, did you? I mean, you did say that, but you also didn't give me like a good alternative to it. But apparently we can just keep it basically in its own while loop and then send it information, basically, through pointers to it, like this. So instead, yeah, so let's just do it on init. We just like literally didn't know what HPV stands for. You've gone through a lot. Yeah, I have gone through a lot for sure. But that's alright. I'm alive and I'm coding 3D cell. So visualization is essential, or do the simulation of the growth in text first? We're kind of at the point where we have the simulation working fine. So yeah, it is kind of visualization and optimizing the visualization at this point. That's kind of what it's all about. Okay, so I'm just gonna do this in there, and we'll just make a new routine. Yeah. Now where am I gonna put this? Let's just do it in. It is technically just gonna be a rendering thing, so let's just put it in render, and let's put it down here. And I'm just gonna call it run thread with td. Okay. And we're just gonna go while true, I guess. We will apparently, so we can wait single object. This is what was the thing here. The handle and that with milliseconds. I don't even know if I need this. I saw this in the sample code, but I don't even think I need this. I think I just literally do it myself, no? I think so. The problem is that this is going to break everything else, especially in here where I block on when I load. How did I make that PC98 music? Using Bamboo Tracker. I've spent most of my life making music. So this is a Windows lib? Oh, what do you mean? The Win32 stuff that I'm doing? Yeah, that's a Windows lib, I guess. Okay, so let's make a global flag that says if we're running or not, because that's the only way we can actually... That's the only way we're going to be able to tell it to stop. Yeah. Yeah, so let's just put this here. Okay. So inside of this function, we need to call populate verts. That's the whole goal here. The thing is, how do we get to there? The name of what? Bamboo tracker? Yeah, sure. It's bamboo tracker. It keeps waiting on an event which will be signaled by the main thread to ask it to do the work. Yeah, I'm not sure what create event is. Yeah, I'm not really sure if that's necessary. We could honestly just put a boolean on the TD that just literally says that it should be going or not. Like, it's not that complicated because we don't need it to be doing multiple different things right now. We just literally put a boolean on the TD that tells it to go. Yeah, we could just literally say if not is done, then just go. Then it just populate verts. Yeah, I'm wondering if I do this in there or not. Also, something else I read was that it's really bad for us to be doing this shit. What I did last night was that I did this, which I made 8 different, for each thread has its own draw buffer, which is apparently this is really bad to do. Which I didn't really know. I thought like if we avoid the mem copy, it would be much faster, but I guess that's a really bad idea. When I was in school, I always used to use switch case and if else statement most. Yeah, that's true. I don't even think we need a back and a front buffer. I think we just... Okay, so that's what we'll do. We'll just go back to one draw buffer because apparently that's the way to do it. And we'll just have these as CPU buffers. These vertex pointer V's, where are they? These will just be CPU side buffers. Hey, what's up, Zaz? Yeah, I think that this is the correct way to go about it. That's alright. I think we do this and make them CPU side buffers. Yeah, so let's just allocate them once right here. The memcopy issue. Yeah, I don't think that we can really. It's really we can't really make it better, to be honest. It kind of sucks, but it is what it is. Okay, so we're just gonna calc it, and then we'll just set it to, what did I call this? Run thread. If not running, break, and then we just close handle. We need to put handle on the TD, yeah. I think that's what it is, right? Yeah. Sorry, have I seen the trailer? John Wick game to play? I did not know they were making a John Wick game. No, I did not. Okay. So we set is done to false here, and that's going to be the kind of the signal for the thread to start going, I think. So let's just get rid of this now, and that should just like send the threads to go. And then when we're done, we're just going to do the same thing, except now we aren't going to close the handle. And also we won't be unlocking or locking the buffer, because apparently that's bad. We also won't be setting v to null. Okay, so we don't even want to wait for multiple objects, do we? Yeah, because they're never going to finish, because they have an infinite thing. No, CA dev is cellular automata. Sorry, I just don't. It's just a really long title if I don't do that. Okay, so instead of writing into, so V is not writing into the thing, it's writing into this, which is real neat and dandy. Oh yeah, so that is what we have to do though. This is what we have to do. When we're done, we have to do the mem copy for each thread. Alright, peace out, have a good night. So now what we're going to do is mem copy it into the main draw buffer, which we then have to lock, right? We're just gonna, since we just have one draw buffer now, we will just lock it once. Right? And then we'll just, so vertex pointer vtemp, and then this will be go to vtemp, and now we need a mem copy. We need to do this outside of the loop, and now we need a mem copy into vtemp from each of the buffers from td. tdi.v size of vertex times td dot vidx, like this. Right. And so we'll have a int cur idx equals 0, and we'll just offset it by this cur idx, and then cur idx plus equals that tdi dot vidx, so that we know where to go in the buffer next. Okay, so that's going to be that's the pattern. Okay, so that's dealt with, and now we need to unlock the buffer. I think it's just unlock, right? Yeah. Alright. That's cool. So when we do this, we set it to threads I. So we have the handle for over here. We have the handle. Yeah, so that's that handle. Okay, so that works fine. Maybe we shouldn't close handle here, actually. We shouldn't close handle from within the handle. I think that that's a really bad idea. That will probably like seg fault us and cause some issues. So instead, what we'll do is, when we set running to 0, we will just wait for multiple objects for what's the arguments? Max threads, threads true infinite, and then we will close all of the handles. Yeah, I feel like everybody left because I was working on that thing and it was not very exciting, so I feel bad. It sucks, man. Doing like programming streams kind of sucks because like if you like for 1 second need to figure something out, then it's like, yeah. So I think what we need to do, yeah, so this is difficult, by the way. This is difficult. Because we can't wait for multiple objects. So what we have to do instead, my chess engine video is legendary. Thanks. Thanks, I appreciate that a lot, actually. Thank you. I'm really happy that that one got big. Because I worked hard on the chess engine for sure. I think instead of that, we have to do this again. So yeah, so we have to wait for them to be done. Yeah, so we have to wait. Yeah, so this has to be in a while loop. This is like a really sketchy thing to do, but it's kind of necessary for our load, for our save and load, because without that, it's not going to. We're going to be touching the memory that we're writing to here, and have that seg fault again. So this is necessary. So if done is max threads, then we will break, and so now we don't have to do any of this. Wait for multiple objects or anything like that, where you just have to set halted to true, and that's fine. Okay, so that's fine. Now the question is reading from the draw buffer. Is anything there going to change? Well, first of all, the allocation is going to change. Instead of doing any of this, we're just going to allocate one draw buffer now, because apparently that's the better way of going about things, according to the internet. Yeah. And instead of this, we're just going to go. Yeah, we have to have a master, actually, a master vertex count. So that's what I'm going to do next. I'm going to do next. So cur IDX can actually be a global. And I don't want to hear. I don't want to hear it. I don't want to hear it about the global thing. I do not care. This cur IDX is what we will reference here when we're drawing. And all we have to do is we have to just put it to 0 when our threads are done doing this. Okay. Okay, so I have no clue. Let me think if this is going to work at all. Well, the first thing that I automatically thought of in my head is that this needs to be in the header, which is, you know, just something that needs to happen. Other than that, I can't really think of anything else, but I'm probably missing something, to be honest. Oh yeah, we need to memset the V to 0 here. We also need to get rid of this line. Oh, we do actually do it to 0 here. We do actually do it to 0 already. We don't want to be changing the thread IDs though, I think. I don't think we want to be changing the thread IDs. We should be doing that over here though. Every thread needs an ID so that it knows what to refer to. Yeah, I think all of this initialization stuff can happen here, actually. We don't want to change the bounds during runtime or anything like that. If we want to, we can do that later. But we could just do this here. This VIDX, we're going to have to change that as well. We're just going to put that on the thing itself. All we need to do is actually do that memset and then set it to not is done. That's all we need to do. That's all we need to do. So this VIDX needs to change. I think that we should just put the VIDX back on the TD, to be honest. So that's what I'm gonna do. I'm gonna take these walking shoes and I'm gonna walk all over you. Okay, so the TD, we're just gonna set the VIDX to 0 at the top of the function and then just use that instead. The reason I had the other one was, it's a complicated reason, but whatever. Okay, don't know if that's it, but I'm going to hope so and press compile. So, okay, we have a lot of things that need to get fixed. I'm pretty sure a few of them are this. Yeah, this also needs to get changed. This, we can get rid of this. Shouldn't be necessary to use it. Okay, so what are we missing? What are we missing? Yeah. Give me the errors, not the... Give me the errors, not the warning. Okay. Okay, so I forgot that. Also, this is not going to be per max threads. That's also a thing. Okay, so this as well, we're just going to release one buffer. Oh. Okay. What? Forgot to cast the pointer. This. That's a global. No? That's not a global? Okay. Fuck. Well, now it is, so whatever. Okay. $35 errors. Oh, that's why. I need to extern it at the bottom. to see the code side by side as I code. Is it not showing up side by side as I code? Is it not showing up? Am I not? What do you mean by that? Okay, we have a seg fault. VIDX went out of bounds. I said the VIDX is 0. Like a Google Doc thingy? Oh yeah, I'm not really sure. That would be pretty neat, but yeah, I mean, this is what I'm coding on is a machine that's, you know, retro and not connected to the internet, so that wouldn't be possible anyways. Yo, what's up, Azalert? I'm glad that it does make you feel less lonely. That's good to hear. This one out of bounds. That one out of bounds. So that one out of bounds. Oh, yeah, that's obviously not going to work. I also wonder if this is too small anyway, because these need to be times channels as well. Oh, that's not the actual allocation. Oh wait, no, it is. Wait, what? Oh shit. Oh, sorry, my language. Yeah, I haven't put it up on GitHub yet. Is my computer going to crash right now? Oh shit, this is really slow. This is really slow. Jesus. Well. Oh, dude, like, I listen to what they tell me. I do the Google, I listen to what they tell me, and they told me the way I was doing it was slow. And now I did it the way that they were telling me to do it, and now it's even fucking slower, so... Sick. No, yeah, sick, dude. That's cool. Maybe I shouldn't be doing D3D lock discard, but like, do I have version control set up? No, but I mean, I could run it back. It's fine. It's like, It's mainly just that, like, I don't know why it's, I may have done something wrong here is the thing. So we could actually just, like, try and think about that. Like, it might not actually be, like, it might have been, like, something that I implemented badly, you know? Might not necessarily be. I guess it's possible that, like, I don't know. That, like, it's like, it's possible that they, like, get out of sync or some shit. If not, TD is done. Then populate verts. And then I set it here. And I mem set that to 0. Oh, you know what? Oh, no. It shouldn't need to be a global or anything like that. I wonder if it's mem copy that's the problem. Apparently there's a set performance. Like, we could actually, like, there's timers, like, set performance, like, get performance time. There's something like that. I have to look it up. A stream snipe. That's funny. Maybe they get out of sync, like... Also, we should not be naming this TD. I should just, let's just call it T, because... Okay, this will sync all of them. Okay. All right. All right. How often do I run into problems like this? What is that supposed to mean? What is that supposed to mean? Just asking, bro. I run into them sometimes, yeah. I only calc this once. What is this? With one thread, this shouldn't be happening. This shouldn't be that problematic. You're wasted right now? What's up? What is up, dude? Maybe you can't use D3D lock this card. Dude, you are wasted. What the hell? No, that's fine. That's fine. I don't care. Why would I care? Okay, so we we don't hit the break point. I'm so chill. Thanks. I never hit the break point. What? How is that the case? I got rid of and not halted. I did get rid of that. But that shouldn't matter. That flag is not related. Not related whatsoever. What happens if I send error? Yeah, I don't think that's gonna help me. I think I just need to put breakpoints all the way through this. But like the weird thing is that I think it's getting stuck here now that I wrote this, but I got a giant fucking smoothie. Because my sister went to the fucking... I did not get stream sniped. My sister went to this cafe with her friend. Yeah, shit's sick, bro. Dude, I'm having some problems with this today. I'm upset. Yo, this shit is fucking gas. Gassed up. Okay, yo, I just figured out what the bug is, and I'm a fucking moron, idiot face. This is supposed to be a T, bro. Okay, well. Never mind. We're still not hitting the fucking breakpoint, brother. We do have a settings panel now. You can check in the Discord to see what it looks like. I'm in the middle of refactoring this, and it's not going well. It's getting stuck here. Whatever. Can you please... Okay, so we hit it now. We did hit the breakpoint now. Okay, we're just gonna continue. Okay. Yeah, it is. I'm looping through all the threads to see if they're all done so that they get synced up. But we get stuck there for some reason, even though it should be looping over itself. And just like see, basically what should be happening, right, is it should just loop through that, see that it is done. We only have one thread right now. It should see, oh, I am done, and then it should just break out, but it's not working. I have no clue. The smoothie's awesome though. This is the same exact thing that I do here. I literally just loop over the max threads and then I wait until we're done. That's literally it. How much weed did you smoke, bro? How much fucking weed did you smoke? Be honest, bro. Is it the Valentine's Day pack? Was that what it was? The Valentine's Day pack. Dude, that shit is crazy. That shit is crazy, bro. Dude, this shit is crazy. Okay, so we're just not gonna do that. We're gonna try this. Okay. Yeah, this is the problem when we have more than one thread, is that my computer breaks now. Yo, what's up? Hey, High on Life. How are you doing? Yeah, this is just so slow now. What is this? Let's celebrate their third super on a live stream. What is this? I pressed the celebrate button, but it isn't celebrating. Thank you. Dude, Valentine's Day is crazy. Okay, but why is it lag? Why is it lag? Oh my god, dude. Like, I refactored this because they said to refactor it, and I said, okay, fine, I'll refactor it, and now it's like, fuck. And now it's like, fuck. I wonder if it's the mem copy. Let me see how to get this performance timer thing happening so that we can see how long this is taking in comparison to everything else. Performance. Is it gonna tell me? Performance counter. Yeah. Performance counter? Bro, I'm not about all that. Jesus, dude. Just tell me how to make a counter, bro. What the fuck is this? Do I donate? I don't know, man. I do not know. I'm going to do a performance counter. That's what I'm doing right now. We're making a new Okay, okay, is this a real thing? Okay, this is not a real thing. Yeah, it's not a real thing, dude. You're lying to me. You lied to me. You lied to me. Performance counter components. Oh, entity component system. I'm googling this shit. I'm googling this shit. I'm googling this shit. I'm googling this shit. Performance counter Win32. Use performance counter tool. Yo, this shit is way too complicated. Okay, listen. Okay, hold on. We got create waitable timer. Why is this so complicated? Why is this so complicated? Timer. You know that song? I can't play it. I'm sorry. It's we got a live version that I can get away with playing and not get copyrighted? Not really.
Now streaming on Hulu and Hulu.
I'm gonna give commentary on what the song means to me, though. You know? And so this is transformative. It's Laura Nyro's Timer. It's one of my favorite songs. It's a religious song about you know, about the persistence of love. It's beautiful. Um yeah, I still got no clue what this shit is doing though. What is this? Okay. Dude, that song is so good. That song is like so insanely good. It's like not even funny, bro. It's just such an insane fucking song. Okay, you know what I'm starting to realize here? I'm starting to realize that even without the mem copy, we are still lagging like shit. Uh, and so I think a few things. I think okay, so we are setting the VIDX to 0 at the top. That is definitely the case. And we do set is done at the bottom. So if that's the case, then then something is off somewhere else. Maybe we're drawing or something. I don't know. Uh, size of vertex. That's the. Maybe the current index is crazy or something. Maybe the current index is crazy. We should probably check what that is. Yeah, let's do that. The annoying thing is that every time I try to breakpoint it, it's like. I'm trying to like think if that's a crazy amount. Trying to think if that's a crazy amount. It may not be a crazy amount. So let's see over here what all of this equals, I guess. So the IDX is 0. The VIDX is 143. And then we add that. Yeah. And then that's 145. So that does make sense. Because it's about 145 every time. So yeah, that does make sense. Service Bank 3, yeah it is. What's up? And how much is inside of Cellverts? Like, we never ran out of... Oh. No, but we... Is it possible that we're running out of space? $32 times 32 times 18. 32 times 32 times 18 times 36 times 3. Yeah, that is a large number. That's 1 million. So we aren't going outside of it. I wonder if it literally is just the drawing. Like, let's just do it without the drawing. Yeah, it appears to be the drawing that is... No, no, it doesn't. No, it's like has this insane lag either way. And I think it's gotta be the threads, man. I think it actually has to be the threads themselves. Um, Actually, it kind of makes sense. Hold on a second. It kind of makes sense because the threads don't have to wait. No, they do have to wait though. They do have to wait because each thread has to wait if it's done, which it does get done at the end of here. It has to wait. Unless something's not makes it not done somehow. Wait, hold on a second. I do set it here. I do set it there. Sorry, I haven't been watching chat. What is XP? It's gorgeous. Yeah, it is. I think your coding is crazy. Thanks. Thanks. I mean, I think it's crazy stupid, to be honest, right now. Maybe it's illegal for me to be touching this memory from the main thread. Maybe this is like I have to do an atomic something. Maybe, but I don't think so. Maybe this does need to be global. I don't know. It never goes out of scope though, so. I've never done memory management before. I don't even think this is memory management. I think that this is genuinely like a thread issue. Like if I do this just single threaded, it'll automatically be better. Okay, let's... The thing is, I only set it to is done false at the top. And TDI should never be touching V when this is happening. It should never be. Dude, yeah, I'm using DirectX 9. Nice to meet you. Oh man, yeah. I think I'm creating like some sort of like a race condition or something. I'm glad I give Terry Davis vibes. Oh man. What are the arguments for this? Creation flags, thread ID. Okay, so we don't need any of that. Okay. Shouldn't you create vertices on a geometry shader? I mean, yeah, if I was using modern technology, then I surely could do that. Okay, I'm just gonna do this here. Just to test if this is still working. Just go back to what it was before, and just, yeah. I don't think that we have to close the... Oh, we do have to close the handle, so I'm just gonna do this. And then just see if it works automatically. Yeah, it does work automatically. Yeah, I don't know why that doesn't work. So that you can't use DirectX content with GeoFW. Yeah. Yeah, having a window manager that isn't Win32 would be quite nice. It would be pretty nice. Now I'm trying to figure out if this is any faster than what we had before. But then again, we aren't in release mode, so we should probably just like test that. Jose? What are you trying to say there? Fast? It's not fast. This is not fast. This is slower than it was before, which is annoying. Or at least I'm fairly sure that it's slower than before. How many threads are we using? 4. Yeah, we don't scale good with threads anyway. Yeah, and we have some visual artifacts happening as well, where the grid gets cut off. Yeah. Because we aren't mem setting something somewhere to 0. God, I hate this shit. Like, stop opening these files, man. It sounded like a... Yeah. Yeah. Man, I love that opening. That opening was always sick. We do mem set this to 0. Here. Oh man, yeah, I kind of want to go back to how I had it before. Like, this is slower. It just is straight up slower. Then, yeah, we're fine. It's just I tried to refactor this to be faster, and now it's just slower. That's the problem. Or as fast as we were before. And there's also these like weird artifacts here. With you can see the green that's here. It's like remnants of the old buffer. Can I know why you're stuck in the past? Because the future is not bright. How am I indexing the cells? Maybe cache locality is the real issue? Oh, I don't know. Possibly. It's kind of impossible to keep them all in cache. I mean, there's, you know, a ton of cells. So... the circles pattern. Yeah. Yeah, it's the kernels that are moving the data around. Z order curves? I'm not sure what that is. I kind of feel like the mem copy is probably what's killing us, but it's also weird that, do I have to mem set this to 0? Yeah. Yeah, I did have to mem set it to 0. Now the bug went away. I wonder if that had something to do with the bug before, but I doubt it. WX widget could be a little replacement for Win32. Yeah, I'm kind of like deep into the Win32 stuff already. Bug? Where's the bug? Let me know when you find it, bro. Let me know when you find the bug, bro. I want whatever he's on. I think that's exactly what it was before. Okay. Okay, this is... who? You, man. Okay, this is pretty fast. With more channels, it gets pretty slow, though. It's mainly the channel issue, to be honest. Like, once you have multiple channels, it gets pretty slow. Pretty fast. You have selective hearing. Yeah, I wish I had that too. That would be sick. I'm super correct, thanks. I'm sure that's not the weed talking, bro. Okay. I look blurry? Do I? I don't think I look blurry, dude. I think you're blurry right now. Bro, bro got so high, his fucking eyes turned into frosted glass. It's like Conway's Game of Life. It is. It's a generalization of Conway's Game of Life called Lenia. After the later stages, we were quite curious to see where it would happen when we had those the old buffering. Yeah, I mean, it'd be interesting to see it now that this bug is kind of fixed, but okay, well that doesn't work still. That does not work still. Yeah, that just crashes the computer. You don't want to do that. You don't want to do that. I think that's not what we want to do. Blank screen jump scare. Yeah. Wait, what? Why is this not working now? Did I oh my god. I think what we just tested doesn't work with the threads. I think that we didn't test this properly. I think I compiled it and then thought I compiled the new version, but then I compiled the old version. Yeah. I commented what? What did I comment? Did I? I don't think I did. I'd get some sort of error if I did. Yeah. Okay, so we can't do this thread thing. Guys, I'm stuck at the reverse polish. It's a simple problem, but until now I'm struggling with it. I don't know if I can help you with that, man. Okay, I think I'm just gonna keep it like this and then we can move on. I think we keep it like this. I don't know. I think the mem copy thing isn't actually faster, so what we were doing before, by the way, was we basically we had buffers per thread. We had 2 buffers per thread, a back buffer and a front buffer, and we were locking them at the beginning of our thread iteration and then unlocking them at the bottom and then swapping the buffers for each thread so that we could avoid the mem copy. That's what we were doing, and then I was suggested to not do that and instead just lock the buffer once, mem copy. But now I'm kind of realizing that whoever was saying that probably just didn't know what the fuck they were talking about, to be honest, but whatever. Whatever, dude. I don't care. So we go per channel here, and that's all fine and dandy. Yeah, I would love to know like what is the most painful part about this, but in terms of like what's slowing us down, but who knows. We can try to like micro optimize some things here for sure. So let's just do that. I don't even think we use mid-val, so I can just comment that out. we do have these points and verts per thing that what is vowels used for again? I don't think vowels is used for anything. I don't think that's used for anything. This V count also isn't used for anything. They have matrix optimization. We aren't really using matrices. It uses FFTW to do the FFTs. I mean, I don't think I use this either. This T count was some stuff that we were doing earlier. We can get rid of the central difference in the CD for sure. We don't really care about the alpha, so we can just do color for all of these vertices. Yeah, I mean, I would love to use perf too, but I don't have perf. I do not have perf. And I don't have their, you know, whatever utility called Performance Wizard, because I only have Professional and not Team Suite or whatever the fuck. So that when the camera's not looking at an object. Yeah, I mean, it has backface culling if that's what you're talking about, and you know, just regular culling as well. But yeah, you know what? I probably could do culling, I guess. But the thing is that the field is so small that you're always looking at everything anyway. So it wouldn't really. Do I even need to clamp this? I don't even think I need to clamp this. Or do floor F. Just cast to int. Just cast to int here. Why exactly am I casting to int here if the points... Yeah, why am I casting to int there actually? Like, it makes sense to get this grid index for this, but it doesn't actually make sense for the actual vertex. It should be... Let's try this. I don't remember when I wrote this code, but I think it was pretty early on, and then I kind of took it for granted, but it's possible that... Yeah. And now I can round it afterwards just so to get check the ISO value. We can just do round spec 3. This guy took way too seriously. The code is AI. What? Okay, so that T count is apparently used here. Oh yeah, so that is necessary. Vals undeclared identifier. Where do I use vals? That isn't, dude. I actually hate all the fucking warnings you get. Is like so annoying. Where is the vals? Oh, the vals is here. Oh, it is necessary. It's not possible. No, it's necessary. Okay. Okay, alright. Alrighty, alright. I may have made a slight mistake. Okay, maybe there's a reason that I had it like that. I don't really... Yeah, maybe there's a reason I had it like that. I thought that the only reason I had to round it was for this. Yeah, at least it doesn't have that indeed. Okay, so it's this. No, I fucked something else up. I did fuck something else up here. Is this vowels supposed to be vowels 12? Fee count? What else did I comment out? Mid-val? Like, I commented out all this stuff and apparently it's used? Okay, it's not used. Wait, what did I do? Is it apparently? I mean, this was down here before. I might just have to run it back. I have no clue what I did. I don't know what I did to deserve this. I'm taking you with me. No, I'm taking you with me. Oh, maybe it was the color. It's only a thing that I really changed. Oh. Huh. Okay, I'm just gonna pretend like that didn't happen. Okay, so it does need to be clamped because of that situation. My eyes. But technically, this should have more accurate stuff going on. Yeah, but we need to clamp it. So we still do need to clamp this. Like that. So... I did the wrong one, my bad. Okay, we are under release mode, so yeah. I think, to be honest, I'm gonna keep it a buck with you. I know we're gonna hate it when I say this. You're gonna hate this. You're gonna hate this. You hate to see it. I've been live for 3 hours, and now we officially are back. Wait for it. Where we started. Okay. 3 hours? I have a computer with Windows XP on it, yeah. It is a real computer. Yeah. Shut up. At least we know what not to do. Yeah, I mean, this is like one of these things where it's like these older computer things. It's like you search shit up and then it just like gives you the wrong. Yeah, this is faster. It's like, it's just faster. Or maybe it isn't. It's hard to tell if it's faster at all. Like with a single channel, it's no big deal. But with when channels increase, it's the same. I think it's about the same. It's just about as fast. It's hard to even notice like any difference, to be honest. Okay, I'm just gonna keep it the other way, actually. You know what? Because, like, I don't know. I don't want to have to redo all this shit again. Like, if I decide to go back. And if this is, like, the more correct way of going about it, then I'd rather just not have to deal with it. With doing it again. But we'll just deal with this for now, and If later we need to change it, then that is what it is. But I don't want to undo everything and then have to do it later. Like that. I'd rather have it and then go back if need be. Dude, you are fucking geeked, bro. You are so geeked. Okay. Okay. Well, that's not good. What is the problem? It's not anything in here, right? I just... That's fine. Well, I mean, now this is fucked. Well, obviously that's not supposed to be in there. I don't know why that was in there. Yeah, that's it. Okay, no, this is 100% slower. This is 100% slower. You cannot convince me that that's not slower. It's so annoying, man. I hate like having to undo your work, dude. Like it's like the worst feeling in the fucking world, but whatever. Oh, okay. You know what? Enough of this micro optimization bullshit. Let's implement flow linear reintegration mass reintegration. What is this project about? It's about simulating cells. Flow linear. Big words? Yeah. I have to remember how to do this shit. It requires like Sobel convolution and shit. Wait, hold on. I'm going way too far back. Or maybe I'm not. Yeah, we should just like go to here. Yeah. Yeah. Yeah, fuck version control, bro. I just press Control Z, bro. Fuck it. Okay. Now the only thing left to do is this. Just gonna go back to waiting for multiple objects. Okay. Okay. Now let's just make sure that everything is fine. Everything is fine. Yeah, that is just plain faster. It's not like insanely faster, but yeah. Assembly to optimize it. No, thank you. No, thank you. Okay, so I have to go to my old code base to fucking figure that out. But yeah, I mean, all of this like optimizing we're trying to do is not making it faster. So I have no clue like what to do anymore. Yeah. Yeah. Yeah, fuck it. I mean, I don't think that I can make most of this faster. Like, this stuff is already pretty fast. Like, we can make this like a lookup table technically. Like, this could be a lookup table, or not that, but this could be a lookup table. But I don't even like, that's not the bottleneck. I think honestly getting FFTW multi-threaded could be nice, but I don't think that we have the ability to do that. We would have to compile the binary ourselves. So yeah, I would have to compile FFTW myself, with, which is not going to be easy because I have to compile it on for Windows XP. So, go here for Windows, compiling FFTW3 for Windows. Yeah, so I already tried this project files to compile with Visual Studio 2008. I can share my screen probably. But this doesn't actually open anything. Oh, it does. Oh shit, really? Okay. Okay, cool. Well, I'll just, I guess, put that on a flash drive. I have no clue how to do that, though. But I need to compile with enable threads, because otherwise, it's not gonna be very fast. I do have a Discord. Yeah, you can join it, for sure. So I'm gonna try and put this on a flash drive real quick. Let me go 7-zip it. Okay. Everything is okay. Okay, I have no clue how to actually compile this, though. So that's going to be a whole other can of worms here. Okay. So this config bench. Okay. Let's just open this up clean. Sorry, I didn't have chat up. Okay. They couldn't put fucking new lines in this shit? Like, are you serious? Are you fucking serious, man? You cannot be serious. Oh my fucking god. Okay, but how do I compile it with threads? How do I compile it with threads? Okay, but what did I say? I said nothing. I said absolutely nothing. Yo, this shit is not okay, bro. Like, how are you supposed to? Do I need to like open up like a terminal to do it? Like, of course I could just build this, but I don't want to just build this. I need to build it with enable threads. Um, pass argument to build files vs 2008. So just like, can I just like set a setting here using ms build properties macros during debugging via the project properties? Okay, but where? Okay, hold on. MS build. Okay. Okay. Okay, so we're gonna go ms build.exe. Apparently, we need that. Okay, so. uh. Okay, hold on. Okay. Okay. Maybe I don't need the slash slash. Yeah, I do remember you. No way that fucking works. Huh? Oh shit. Hold on, hold on, hold on, hold on. Okay, okay, okay. I think, okay, listen to me. Hear me out here. Hear me out here. The reason why this isn't working, by the way, is because we aren't in this directory. Okay, we need to actually navigate to this directory. Oh man. That's fucked up that I gotta type that again. How do you do this on Windows? Is it just this? Yeah. D slash. How do you do this shit? Do you just do this? Oh my fucking god, bro. Now you use CD? Oh my god. Bro, what the fuck is fucking Windows, bro? Like, actually. What the fuck is Windows, bro? Okay. Motherfucker, I'm in the fucking... Okay. Hear me out, hear me out, hear me out. I think we need to go one deeper, okay? We need to go one deeper. Bro, what the fuck are you doing? Bro, the thing is, that is definitely inside of here. That is 100% DFT, scalar, whatever. Like, this is definitely, all this shit is... Okay, there's nothing in there. This is the problem. It's 108 kilobytes. Okay, hold on. Maybe. Okay, maybe. Okay, hold on. Maybe we just need to do it from scratch. No such file or directory. Brother, you just made the directory. Now put the shit in it before I lose my goddamn gourd. What? Okay, I'm just doing it from in here. Cannot open source file. Okay. Okay. Okay, hold on. Oh, wait. All this shit is in here. Have pthread? Have... Okay, but... I need other threads. The readme was a red flag. Yeah, you're telling me, bro. Using POSIX threads, using NMP threads. I guess POSIX threads, right? But pthread doesn't even have a thing. Like, we can't even use pthread. What is MPI? Is MPI what it is? Is it MPI? MPI library. Is that the threads? Maybe that is what it is. MPI library 132. Is this the thing? Okay, so we can't use. Can we use OpenOMP on? We can't, right? Oh fuck, we can. Okay. That's cool. Okay, so OMP is the thing. OMP is the thing. So no. We're just gonna define. Okay, we changed our config.h. The problem is I still have no fucking clue how to build this shit. Maybe I need to put it onto the hard drive. Maybe it can't be on a flash drive. That might also be it, I guess. Let me read the README again. Okay. This part, yeah. It's created to build, yeah. Release static. All builds rely on a properly configured. The one provided should be sufficient. All builds. Okay, I mean, I'm just gonna copy it onto the fucking thing. Shut the fuck up. Bro. Okay. I'm just gonna go here instead, okay? Do I actually? I have to put the solution, right? I have to. I think that's just you, bro. You know, okay, here's oh, okay, okay. No, I figured it out. I figured it out. I figured it out. I figured it out. We don't have all the sauce. We don't have all the sauce. No. We pulled up to the party without all the sauce. No, I figured it out. We don't have all the sauce. We need to also get the other sauce. Okay. What version is it? We need 3.2.2. Okay. 3.2.2. Uh-huh. And where is that? Older stuff. 3 point FFTW 3.2.2. Okay. Okay, that's not it. Okay, I got it. Yes. We have it. What I'm doing right now is some crazy shit. Hold on. I'm just gonna make a new directory called new, and then that. Okay, so I realized that we are getting errors because we don't have files. And we need to get the files. That's what I realized. And so I'm downloading the files. I'm unzipping the files as we speak. It's my own fault that I assumed that would come with the files, but those were just the project files. I need to get the files to put into the project files. Yes. Okay, so it was looking for files that that didn't exist. I was wondering. All right, well, that's cool. All right, so now we'll just put this shit in here. And then Play ball. Yes, I do have Maya. I've been trying to learn how to. Yeah, this is taking forever. Man, this is a failure of a stream. I feel bad. Usually it doesn't go this poorly. So far, everything that I wanted to work on has not worked. Oh, come on, bro. I need to get the other ones. Okay, well, I just cheated by pressing Alt, but... Dude, this game was my childhood, for sure. Do you know what this guy earlier taught me? Did you know about this hidden test thing? Did you know about this? That you can type in hidden test, and then you can cheat? There was a guy, yeah. There's a guy that said that to me. Oh my god, a game. Yeah, watch this, watch this. Oh. Dude. Okay, maybe you gotta do a new game. I'm telling you, this thing is real. Okay, well, I can't do it now for some reason. Okay, well, whatever. Apparently this is something that you can do. Okay. Okay, we have to eject this flash drive now because I think it's done. Yep, 7-Zip said everything is okay. And if 7-Zip says it, then that means it must be okay. Alright. I don't know what that was about. New. Okay. So... Okay, so now what do I do? Like, I'm just gonna copy the folder, or... This apparently needs to go in release, I think. Because that's where it was looking for it, inside of release. I think. I can't really remember. Let's... Oh, shit. I need to make sure because I don't want to just, like, copy the files in the wrong folder. Do you remember? Oh, you don't remember. You do not remember, you fucking prick. Okay, we're just gonna pretend like that didn't happen. Okay, I'm just gonna put it in release, and if it's bad, then whatever. Do you remember? Okay, we're gonna put it in release because that's where all this shit is. Imagine having a memory. Bro, what did you take? Genuinely, bro, are you good? Alright, we're building this shit. Bro, you have to be fucking joking, bro. ... Like, where is it looking for this file, bro? Like, okay. I guess it's looking for it here? Right? Oh my god, I think it's over. This is so fucking stupid, man. I'm glad that you decided to share your drunk day with me. I take a lot of enjoyment in that. It's over. Yeah, it's over. Yeah, how long did this take? Like an hour? Excellent. Did you know that Leonardo DiCaprio is a bad guy? Unless I need to forget. Jesus, bro. You didn't have to make it that hard. Jesus, bro. Don't drink to forget, bro. Bro? Bro? What does that mean? I don't think I want that. What the fuck are you talking about? Okay. Nah, I'm good, bro. The fucking System 32 EXE, bro. I don't know about that. Okay, but where is it? Where the fuck did you put it? Is this? Is it the lib right here? Output. Okay, dude. We fucking got there, bro. That's what I'm fucking talking about. What's in Leonardo do? This isn't VirtualBox. This is my real computer. What did Leonardo do? I don't know. He's just a bad guy, apparently. He's like kinda, I don't know. There's no real allegations, but from what I read, bro, he's a bad guy. He's a bad guy, bro. So where the fuck do I put this shit again? I gotta go into here, and then I gotta go into here, and then I gotta go into here, and then I just fucking copy and paste that shit in. And that's the libff, right? This is the correct folder, right? I'm not fucking tripping. Yeah, libffdw. And now I think I just get rid of this one. I'm gonna just put this shit in here and then delete this shit. Oh, fuck, bro. This shit... Oh, wait a second. Oh, no. I don't think we did floating points. I don't think we did floating points. I think we did doubles. Yeah, we need to do... Wait, what? Single precision. You don't want single precision. You want floating point precision. So you're telling me that this is floating point and we don't have to worry about it? If it's not double and it's not single, then it has to be floating point. Right? That's the only other. That makes sense to me. Okay, we're going to go to include. And we got ffTW3.h. And now we get rid of the other one. Wait, I don't even think that shit is in here. Whatever, bro. Okay, so now let's lock the fuck in. Let's open this again. Now this probably isn't going to work, okay? It's probably going to be like, oh my god, I can't find the header file. That's alright. We gotta go here, and we gotta delete the old include. The old rigmarole, bro. See? Yeah, yeah, yeah. You gotta delete this shit, okay? Apply that change. And now it should automatically find. Okay, we failed. Okay, but cannot open input file libfftw. Okay, hold on. I chose the wrong one. We have to go to linker. We don't need any additional libraries anymore. We just go libfftw.lib. That should be what it's called. What are you talking about? Oh no. 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 I think it's because it's floating point, bro. It's because it's floating point. Ah, shit. Hold on a second, hold on. The way we need to test this is if FFTW complex A. What type is this? It's a fucking double. Oh my god. Why? Oh my god. Is long double a float? Is that what it is? Long double. Is that a float? No, it isn't. What are you talking about? I'm writing it myself. Is single precision? Single precision is not floating point, no. Wait, it is. Wait, it is. Oh my god, I'm just so dumb. Because I don't usually see it written like that. Okay, so then I'm not going crazy. This does exist. No, Shut up, 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 shut up. Why is this? Hold on. Maybe I need to restart it. Dude. Do I need to like delete this again and start over? Maybe delete the cache? Like, delete all of this and then just go again? Okay, there we go. Yeah, that's so weird that that's problematic, but whatever. The reason why I didn't think that was because they also have like integer precision, I feel like, on their thing. But maybe I'm just dumb. Oh, man. I wonder how much faster this is actually going to make us. It better be like super fast. Okay, so hopefully okay, but why is it unresolved external symbol? Hold on, hold on, hold on. Hold on. I do have libffttw here. ffttw3.h. I can definitely find this file, right? Like it's not gonna miss this file. It really shouldn't. Like, it's like inside of the thing. But I can try to like just straight up point it back to the lib folder, but I doubt that that's going to help. But there you go. I just realized I paused the stream. Oh, that's fucking hilarious, bro. That is hilarious, bro. That is insane, dude. It's a linking thing, though. It isn't a header thing, or else we wouldn't have the thing. Unresolved external symbol. Bro, like, what do you mean? This is called libffttw. It is. Like, uh, uh, bro. It just deleted my other fucking libraries. Oh my god, I'm gonna crash out. I'm gonna fucking crash out. I'm gonna crash out. I'm gonna crash out. I'm gonna crash the fuck out. Oh my god. This is so fucking annoying. I'm actually like pissed, dude. I am so pissed. I'm so pissed after that. Holy shit, that just pissed me off so bad. Oh, brother. Alright, we need these libraries. And we're gonna go here. I can't believe that it fucking just overwrote everything. That was so fucking ridiculous. Okay, here's what I'm gonna try. I'm gonna try to do FFTW complex A. The thing is, it's the functions that are the problem. Okay, so if I do FFTW init threads and I just like leave it here, will it have a linker error? Just without the F. It does. So it has nothing to do with my precision. It's yeah, I mean, I don't know. I do not know. Maybe it was like... All builds use the SSE2 extension. What is it? SSE2? Okay, so it's only on Intel. It's simmed instructions. But I feel like I would be getting a different error if that was the case. Like, I feel like I would be getting like a different error. Like, it would be telling me that it can't parse the DLL, or it can't parse the bin or whatever. But it's not telling me that. It's not telling me anything. No. That's cool. Yeah, looking at how people do macros just blows my mind. I never come up with shit like that. That's always cool to see. Yeah, I don't know. Yeah, it's getting mad because of the DLL. Wait, what? Cannot open file. But I don't have it in the link list. Like, my last attempt here is just going to be to like drop this into, or maybe, you know what, I should just try to actually just straight up link it to the file itself, like straight up the fucking, go to here, just straight up go to there. Just, I don't know. Just, yeah. Nope. Yeah. Library developers are just different. Yeah, it's crazy. What language I work? I work in C. Yeah, I don't know. Yeah, I don't know. Maybe we can try building it again, I guess. I'm not really sure at this point. This is Windows XP. This is, yeah. This is. Maybe it's some of the stuff that we changed in here. Let's try no OMP. Try no have threads. Try no using OMP threads. That's everything that we did. I'm going to get rid of this optimization. Do I have limits.h? I think I do. I think I do. Alright, I mean, let's just give this a shot again. I doubt that this is... Oh, wait. Fucking stop. This... Hold on. Do you have to put both of these in? Maybe I need to put both of these in, but bench FFT I think is just something else. I think bench FFT is the other thing that they have. I don't know what it's used for, but it's like a separate thing. Okay. To be honest, I thought that this was going to work after we got it working, and then it didn't work. So I already passed it to that folder, so it should be fine. The header probably didn't change, but you know, we should probably delete that and just set it back to the exact place that is at. So in here. Yeah. Yeah, I don't know. Yeah, it's like I can't figure it out, and it's like not like something I can just look up how to link old FFTW version. It's not something that I can do. Hold on a second. You know what? Hold on. Wait. Hold on. Let's think about this for a sec. What about the DLL? There isn't a DLL that we're getting out here. I would love to get the fucking thing, dude. Yeah, it's here. I need to go. Maybe I need to rename the DLL. To that, because that's what it's expecting. No. The thing is, this doesn't even give me a DLL. the thing. I don't get a DLL out. Why is that? Win32 output.bin. I don't have an output.bin. It does not give me a bin. Hold on, maybe we aren't doing this correctly then. Hold on. Maybe I need release DLL. I think that's what it is. Hold on. I'm just going to put back the stuff that we got rid of to test. I don't think we want this because I'm not on Intel. Do this and the this again. Okay. Your message got retracted. Yeah, I'm sorry. This hasn't been the most exciting experience. Whatever though.
One of the things that you learn in the Army specifically are the Army values: loyalty, duty, respect, selfless service, honor.
Oh, I'm stupid. Oh my fucking god. I thought that would automatically switch it to the release DLL, but it didn't. So now we have to wait again. Yeah, I bet that was what it was. I don't know why the default isn't release DLL though. Like, I noticed that there wasn't a DLL, but I didn't really realize that there was. Like, why would you not want the DLL? Okay. Yeah, if this doesn't work now, I'm gonna be pretty livid. Yeah, I thought that I had it there. thought I got rid of this. Yeah, sorry I don't speak Russian. Yeah, I thought, yeah. And I'm going to assume that putting it inside of here is not going to help either. Maybe it will actually, hold on. Yeah. Yeah, I don't know. Translate, please update Windows. That's funny. That is funny. That is pretty funny. I mean, isn't it guaranteed to check my project location? Like, it has to be guaranteed. Yeah, I don't know. I don't know. I wish that it told me, like, what file it's looking for. Like, it doesn't actually, like, say. Like, you know. Like, if I'm supposed to rename this something or what. It just doesn't say. So I've genuinely no clue what to do about that. Yeah, I don't know. There's nothing else that I can really do, so it is what it is. I tried I tried my best. Yeah, I mean, the fact that we don't get any compile errors and it just goes through just probably means that I'm like shit out of luck and I should just give up at this point. Yeah, I think maybe I just have to give up for now and then like try this later off stream. So that is what it is, I guess. That's really really big bummer though that I couldn't get it to work. The stream paused for like 30 minutes. You pause it again. The library search paths, yeah, it is. It is. I've like double, triple, quadrillion times I've checked it. You know, it's... We've got the include directory. It's not a header thing because it finds the header. It's a linking thing. And I have this that links to the library. And I have the lib file here. And I shouldn't need to link the DLL manually. I've never had to do that before. You just need to put it in the folder, and I already have. So I don't think I need to do anything else with the DLL other than put it in the folder. Unless it's looking, so the thing is, like, it might be looking for a DLL with a different name, I guess. But it, like, I wish it told me, like, gave me a name, like, cannot find DLL or cannot find this or whatever. It's not telling me anything. It just says that it can't resolve the symbols. So, like, it's kind of, like, really annoying because if it, like, told me something like can't find the, like if I do this, it's gonna find this, right? So this DLL here, what is this? If defined FFTW DLL for Windows compilers. Okay, let's try that. No. If I had to guess what it is, it's probably like that, like it's looking for a DLL with a different name, maybe. Because the names aren't always like the names that is here. It's supposed to be like FFTW33 or something. Does my face cam not feel real? It's kind of, you know, it's an old one. How's America? It sucks. It does suck. Yeah, I don't really know. I'm kind of stupid, so I'm... The DLL is called this. And the old lib was this, which is different. I probably tried changing the name. It used to be, the naming convention was 3F3. I don't think that, the thing is that's for 3.3. That's why it has a 3 at the end. So I don't know if that's supposed to be it, we can try that. And just drop it into all the folders and see. Stack Overflow? Bro, why do you keep pausing the stream? Chill the fuck out, bro. I do get it. I get it. I get it, bro. I do get it. I hope you're okay though. Like, no, yeah. I mean, it's still. I'm not gonna run that command. Okay, well, I guess. Okay, well, I guess I've had enough. Like, it's at this point, it's just ridiculous. Let's go to one of these files and then like see where it takes us. The thing. Do you think, how crazy are we? Do you think that we should just like drop the entire library into the project? Yeah, I know what it does, dude. I'm not fucking stupid. Yeah. It's pretty funny to like come onto a programming stream and be like, yo, delete your hard drive with this secret command. Do you think I'm fucking stupid, dude? Like, I mean, like, how crazy would it be to actually just, like, take all of this shit and then just drop it into it and then just do it myself? At this point, I feel like it would probably be easier just to do it myself. Maybe some are missing. No, the thing is, so those different files that you're talking about are for different precision, right? So, libffdw3f is floating point precision, right? So, yeah, but like I said, I guess like before we try, like this is what it's supposed to be, right? So we can try that. It's like the last ditch effort of like trying to get it to work. But yeah, let's do that. Let's just do everything 3F3. And then if that works, we just give up. But that -3 at the end is for FFTW version 3. So okay, now we have 3 different DLLs in all of these folders. Three different DLLs in all the folders. I mean, today's a disaster. Yeah. Yeah, I don't know. Well, it's a bummer, but oh, hold on. We have to go into here, make sure we're in all configurations. Oh, it's being fucking weird. Okay. Put that there. Yeah. Yeah, I think I have to give it up now. Yeah. I even did this this define here to try and fix it, but yeah. All right. I think I'm just going to undo all of this and just, you know, I guess I'll come back to this and try it later, I guess. The tricky part is now, like, how do I undo all of this? I'm not really sure. Okay, let's try though. So the old DLL was larger. Yeah, this is kind of fucked up because the old DLL okay, well, this sucks, but I think I have it on my flash drive, the old version in here. Yeah, I have the old stuff in here. What I'm worried about is do I have backups of the... No, I don't think I have backups of the other stuff, but whatever. Yeah, what I'm worried about is I don't think I have backups for the... Oh, I do have backups for the lib. Never mind. I'm just freaking out over nothing. This header is the one that needs to go. We'll just replace the header in output since that's there. Just delete that. And then we'll just replace the lib with the one that we have in FFTW. No, not in here. It's in here. It's in here. No, it's in here. Actually, it's pretty weird that it's in there, but yeah. It's in here. So this is the one that we need to link now. I think it's actually, this is the name. Let's see if this compiles. Maybe not. I think it's probably the header that we changed the name of to this. What's the issue? Unresolved external symbol. FTW init threads. Oh yeah, because we have the floating point precision one. Yeah. Okay. Alright, well, that sucks. That really blows. I thought that we could get that done, but I mean, then again, we are trying to compile something on Windows XP. So I guess it's not easy, you know. Why are we on Windows XP? Because it's like challenging, it's pretty fun. Yeah, it sucks. I didn't really get anything done today because everything has kind of not worked. So that's unfortunate. But that does kind of happen sometimes. Anyway, I have to kind of remember how to do this shit if I want to do the Sobel convolution. I'm just trying to. I'm in my old code base right now. I'm trying to find the. Yeah. Okay. So. Let's make an outline of what we need to do. So first thing, we have the old kernel loop. The second thing, we have the Sobel sum into nabla a, and then we have a Sobel convolve with into nabla u, and that uses h. I can't really remember what h is. I think I have to remember what h is. But h into nabla u. This actually isn't nabla a that we use for the second step. Then we use the compute f, which is grids times nabla u times nabla a, and then we have to compute mu, and I don't remember how to compute mu. That's a complicated formula that I have to look at. And then we have the reintegration using f. Yeah, I don't really remember the mu formula. Let me look it up real quick. The mu formula is interesting. It's f times delta time. It's time step actually in our convention. What is pause array? I have to figure out what that is. Yeah, I have single precision. Yeah, I have the DLL. I had the DLL in there. It just was not linking. Once again, I have the precompiled DLLs work fine, right? Which is what we already have. The problem is what I was trying to do was compiling it myself so that we could multi-thread the FFTW stuff. But for whatever reason, I cannot get it to compile properly. So, but I'm not surprised at all. Even on the FFTW website, by the way, it says it may not work. It literally says, I can read it to you. I was hoping that it would work, but they even say FFTW installation on Windows. Here it is. Visual C++. In the past, several users have contributed Visual C++ project files for FFTW, which you can download below. However, many older versions of Visual C++ generate incorrect code for FFTW. VC++ 2003 definitely fails. VC++ 2005 may work, and VC++ 2010 has been reported to work. So, yeah, I'm not like insanely surprised, right? But yeah. Let me figure out what pause array is. Init pause array. Okay. Okay. Okay, so that's that array. I was trying to remember how to do that. What that array is. Yeah, sorry, I'm looking through my old code base to try and figure out what the... yeah, compiling, libraries on, Windows XP isn't easy, so I'm not like... I'm just kind of bummed out because that would have made our code like 2 times faster, you know what I mean? So it's kind of a bummer, but whatever. I can probably figure it out later, but I'm definitely going to have to like get my hands dirty with it and like really try and figure out what's going on. But I'm not going to do that on stream because I've spent like 5 hours just like banging my head against the wall today. What does this code clip between do? Isn't that just clamp? Okay, so yeah. So this compute mu, this is what I was trying to remember, is f times dt. What is ma? What is ma? What is this variable? Oh, it's a variable that I take in. C.off. Oh. Right, there's an offset table that we have to compute as well. Oh. Let me look that up. C.off. Off table make. Inside this other file. Off table make. Yeah, I forgot what this what the code does here, man. That's crazy. Okay. So row size is going to be 2 times dd plus 1 times I don't remember what dd and sigma are supposed to be, but they're kind of like constant values. Dirty hands, yeah. Dude, do not yak. Do not yak. Do not yak on me. Okay. Don't ask what any of this shit does because I barely remember. Okay, so this is all the offset table stuff. Okay, so the offset table is what allows us to properly calculate some stuff down here, which is what I was trying to figure out. Yeah, the Sobel convolution stuff we can figure out. It's not like crazy. Okay, so this is the F formula. It's not grids times, no. It's their specific, this is the mass reintegration stuff right here. So this is, it's nabla U times 1 minus alpha. Right, we also have to calculate alpha there. Minus nabla A times alpha. Okay, so that's their formula, right? That's straight from the paper. And so alpha is, okay, so to compute F, you have to loop through channels, cells, and then, so this is one step, right? Then you have to compute this through the, it's cell divided by channels. Divided by the amount of channels. You're basically finding the mean here. And then this is squared, and then you divide it, and then you clamp. 0 to 1, I believe. It looks like these comments are going to be the bugs for next stream. Yeah, I mean, this is not going to be very easily. We're not going to get finished with this today, but, you know, this is kind of like the next mathematical step in here is to do more physics stuff. We want to do more physics stuff. So now after we compute this, we need to loop. Right. F is the last index of here is like, this is X, Y, Z. So loop X, Y, Z. Yeah. Okay. So that's how you do that part. Then this is F times time step. F times time step clamp negative MA to MA. And MA is what we calculate up here with the off table. That is right. Then this is the part that I don't understand. This pause array. No, this isn't mu. This is right. Okay. Yeah, this is so fucking confusing. This pause array. Okay, the pause array, by the way, this y is inside of the x component. That's what I was trying to... This is why I was confused, right? So the reason why I'm pausing on this is because this is going to be in 3D. So I'm assuming that this is going to be like this. That's what I'm assuming we're going to be doing. Right. Okay. Got it. And then... Yeah. Okay. Got it. Got it. I'm trying to find where the actual reintegration step is, though, and I can't remember. What is the reintegration step? Oh my fucking god. Dude, this is crazy. That's crazy. Yeah. I don't know if we can do this. I thought like this might be cool, but when you stuck at a problem in your code for days, do you read other people's code or do you try it? I sometimes read other people's code, yeah, it sometimes helps. Yeah, this reintegration step, I thought that this was the easiest part, but it's actually the hardest part. Okay. So let's focus though and not get too caught up in it yet. So the Sobol sum, what does that consist of? Is it Sobol convolve sum? It is... It is Sobol convolve sum. That's the... So both are convolutions. By the way, this is happening once a frame. Yeah, bro. Okay, right. So right, the arrays are always the same. So Sobel convolution, if you don't know, is how they do like that edge detection shit when it comes to like photos. So what we're doing is the exact same thing, right? It's just a kernel. Uh, oh fuck. Oh shit. Nah. Yeah, doing this in 2D is a lot easier than in 3D. Bro, this is crazy. Um, I don't think that this is feasible in 3D anymore. So for example, so this is what it is, right? So this is what it is in 2D, right? So if we were to, right, and then, so this is in the X direction, and then this would be in the Y direction, it's just swapped. It's just, this goes up here. It's a matrix swap, right? So you end up with that, yeah, and then these are all positive, and then these are just zeros in the middle, right? So it just swaps it on its side. The issue is, how do we do that in? Ah, shit, bro. That's really hard, actually. That is really hard, actually, because you end up having to. Don't you have to do? You have to do this. Oh shit, that's difficult, man. Alright. I have to use the bathroom. Okay. I'm gonna Google. Sobel convolution 3D. Has it? Oh no. Oh no. Hold on. Extensions to other dimensions. A 3D kernel in Z direction. Wait, what? The fuck are you talking about, bro? Like, what does that mean, bro? Oh, so that's the middle. Oh, shit. Okay, that seems cursed to me. Yo, thanks, Michael. I'm sorry if I said that wrong. Thank you. Okay, so if we want to do a 3D Sobel, okay, this we need to do 3 of these. Unless I'm reading it wrong. No, maybe not. Wait, maybe that's just them on top of each other. Maybe, hold on. Maybe we can do both of them in one. I had them separated before, but apparently you could do... God, it's so hard to actually think about this. Because this is difficult. Maybe there's a better... Okay, so they're just saying do it with NumPy. That's what they're saying. You need 3 operations with 3 kernels. dx, dy, and dz. Yeah, but then why is dy not not why is this one... What? Okay, so here's what this says, right? So for z, it says that it's basically a 3 by 3 by 3, okay? What's confusing... is why it's a different dimension than the other ones. So it's like the one that I'm looking at. It's strange because at -1, it's actually positive. So it's like the opposite. It's this. It's that. And then of course it's different at these different no, this is actually negative. Yeah, I was actually off here. That's -2 and this is -1. And then this is -2. So they're symmetrical. Right? So this is the same as the bottom. I'll just keep the +2 just to be explicit. And so the middle is actually, oh, the middle is just zeros, just complete zeros. So basically it's this expanded into another dimension. The thing is, I don't know, do you really need to convolve with with all of these now? Yeah. So I'm wondering if you need these still, or if it's just this. Because from what it looks like to me, like it looks like that these are included inside of here. Okay, so according to this, you still need the x and the y derivative. It's just weird because x and y are in 2 dimensions, and this is in 3 for some reason. Wait, no it isn't. I'm trying to read this paper right now on it. But I don't think that they're actually going to give me the values. I think that they're just going to be like, oh, here's the conclusion. Yeah. They basically say, oh, calculate it yourself. Yeah, they basically say go calculate it yourself, and I don't know how to calculate it. If I had to guess though, Wouldn't it be like this, but... Wouldn't it be like this, but, like, would it be like that? Or not? I wish that this gave me the formula. Yeah, if you want to see what I'm looking at right now, it's this. Hey, the Atom W optimizer, that's crazy. Okay, so they don't really tell you how to actually make the kernel. So that's cool. Now, yeah, I didn't want to make the kernel. Oh, God. Yeah. And the formula itself is just like... It says that there are 3 3x3 kernels. And then they only give you the one in the Z direction. And not in the X and the Y direction. I have no clue. And then this isn't actually... I don't think that this is it. We can just roll with this for now, but I don't think that this is it. Because the sum isn't the same. So it can't be that. It cannot be that. Yeah, the sum isn't the same. I would love to just skip this for now and come back to this, but this is actually like the first most important step, is getting this Sobel kernel down. Yeah, this is frustrating. This is frustrating. Okay. Okay, so this is okay. Let me look at my code for this again. Hold on. Yeah, but you still need a third kernel. Because you still need a third because you're looping through it. Yeah, you're looping through it. Uh So is it saying that I saw this Stack Overflow that's like since the Sobel filter is separable, you can apply 1D filters of each of X, Y, and Z directions consecutively. If you do HX times HZ times H does it help? Does what help? This Stack Overflow? Not really. I'm trying to figure out how to do Sobel convolution in 3D. Uh, oh my god, this guy actually has them. Oh no fucking way. Oh my god, dude, he has PNGs for them. Oh my god, this random, not even the top Stack Overflow, this random guy at the bottom has it. Oh my god, my fucking savior. Oh my god, dude, I would have been, I was lost, man. Okay, so these are the values. So this is, so wait, hold on a second. I plus 1, j minus 1, k plus 1. Ah, shit, man. Do you want to see, if you want to see what I'm looking at right now, I'm looking at this. This is the X direction. The 3D in the X direction. I'm gonna guess that this is -1. Right? We're looking at, yeah. So, wait. I is going this way, though. With J? Wait. But J is Y. Holy shit. Oh, wait. This is -J. Oh, -K. Okay, but that's Z. This is X. This has to be X. You're fucking joking. Dude, what are we talking about? Wait. Hold on. Hold on a second. Oh, it's just this flip side. Wait. It's this. Ah. It's this in a different configuration. It was deleted. Oh, sorry. Yeah, I mean, I didn't delete it. Okay, hold on. Okay, so we. Oh, wait. So it's three different ones. We got to compare them. So this is. No, this isn't the Y. What is it? What is this blue shit? Okay, so in the X, the Y. Okay, so they all have the same origin. So this is what we have. Except ours is flipped sideways. Oh, no. This is what we have. Yeah, it's exactly what we have. In that order. So I'm going to assume that they're all in that order and that we're good to copy them and not have to worry about which one comes first. Every source that I looked up had basically was saying, you're shit out of luck with it. So I'm happy that we're not, because I was about to crash the fuck out. At least there's one thing that went well today. At least there's one thing. Okay. I have to make some progress before I end stream today, or else I'm going to lose my shit, because we spent a billion hours trying to fix this and do this and optimize that, and none of it worked. So it's I've got to get this done, or else I'm gonna be pissed. Sorry, I'm just copying all of it right now. So these are going to be the three kernels that we have to convolve this stuff. And we need to convolve twice. Okay, we got it. Oh, I got it. Okay, so now that we have the kernels, that's all good and dandy. Look at the image started rendering at last. Yeah. Oh, really? What was it? Something? I don't know. Okay, so this is our Sobol kernel in the Y direction, in the X direction, and in the Z direction. So yeah. So we have to Sobel convolve the sum into nabla A, and then Sobel convolve H into nabla U. And the H, if I remember correctly, is I think it's the magnitude of the cells across all channels. So we have to do that. Which is not going to be easy. It's not going to be easy at all. I'm going to close the window. Okay. So let's figure out what's going on here. In this function that I called Sobel convolve sum, we're taking the sum of a buffer. Okay. We have a sum buffer that we allocate to width and height. And we add the real component of our cells into it across all channels. Okay, so let's make a comment here. Some buffer total across all channels. Okay, I thought that that's what H was, or K, or whatever, but I guess not. Okay. Now we need to loop X, Y, Z. X plus dx. Why is it dx plus 1? I'm trying to figure out because of this. This is like weird why I did it like this. Sorry if you're confused. I'm looking at my old code base right now. I wonder why it's plus 1. Okay, so that's what that's doing. And the other one is doing the same thing. It is strange though. I go the x plus dx, which is us going around the thing, and then I add 1 when I actually index into the kernel, which is bizarre. Oh, I see. Yeah. Because -1 equals 0 in kernel space. Yeah. Okay. That is true. What am I making, bro? I'm making, well, I already have made like a 3D implementation of a 2D cellular automata, which is this. We tried to make the normals look a bit, pretty today, but it didn't really work. Anyway, the reason why it's laggy is because I don't have it compiled to release right now, but so that's what we have been working on. Yeah, it's cool. Yeah, the release doesn't work because we were trying to link it something earlier. It's complicated. Anyway, now I'm uh, going through the math in preparation for doing some flow linear ideas here. So that's what I'm talking about. It's going to involve Sobel convolution in 3 dimensions. Yeah, which sucks. It doesn't really suck. It's just, you know. But I do have a gyro, which I relatively need to eat. So I'm sorry, I've been here for like a while now. I need to eat, so. Have fun, read away. Read away. We have to figure out what H is. I forget what H is. What is H? I thought H was the sum. Yeah, it is. H is the sum growth across every channel. Yeah, I forgot about that. Dude, this shit is really good. Alright, so bell convolution, man. We gotta get on the road. That was really good. That was really fucking good, bro. It's an Indian place. I think that was lamb. Alright. So bell convolution. Sorry if Nightbot doesn't work. I think it does. It just takes a second. Alright. First things we need to get ready with are the offset table and the pause array. Are the first things. Offset table, it needs a DD and a sigma. I don't really remember what the DD and sigma are, but I think that they have like just known good values. Like sigma is like 0.05 or something. Nice build, thanks. I built it a long time ago and it just kind of works. I can't use it unfortunately with my Windows XP computer because the driver just doesn't enumerate properly, so it kind of sucks. I probably have to like program it myself someday. Alright, so let me look at what the off table is, what it's called. And this, basically I've made this in 2D before, and so now I'm trying to remember what this is like. So we have these two variables, sigma and dd, and so I'm just going to write down sigma hold on. Yeah. Okay, well, I actually not going to be able to find what it's like. Basically, the way I started doing the RAND things is that I started doing like some Monte Carlo sort of row-based RAND seeding. It was super fucking complicated for some reason. Anyway, I think the DD is sigma plus 0.5, and I had it seal for DD. And then for sigma, I had this, I had it as 0.1 plus rand, basically, times 0.4. But I'm not sure what this was scaled at. But apparently, I wrote next to it that 0.2 to 0.8. So those are our starting values for this. Okay, so let's just make the functions to do this. So I'm just going to do init pause array. Pause array will just be a global constant variable. Basically, unless we have to reallocate the size of the board. So we're just going to make it a const. Yeah. Okay, so this is fine. So let's just make, this is going to be a float. And it's just going to be, let's just keep it defined for now. Okay. And we'll just put this, yeah, I hate when it opens this shit up. I'll just put it up here. And so we will just initialize this down here. So we need to loop through like so. Do we need, no we do not. It's not that big of a deal. Okay. Now, is this going to be actually feasible in terms of like this working in 3D? I'm really not sure. This is where it gets to be basically like a real physics simulation and not just like particles. We're talking about like mass movement. Okay. All right. So apparently, all we need to do is store in the pause array. I'll check this later, but I'm pretty sure that all we need to do is store in here at the index. Pause array. Right. Okay. I wonder if I want to make this a vec3. No. No. Just make it. We'll just do this. Sure, it's a little bit more confusing, but I think that there's some reason why we can't do that. Or else I probably would have done the other one of vec3, but yeah. So this is going to equal z plus 0.5f. I'm not really sure. I can't really remember why I did this. But basically, you're trying to get the opposite order. And this helps you iterate things later without computing things. Now our sigma and dd, we can just set as globals. And we'll just make them yeah, let's just do like 0.4f, and then this will be 0.9f. So these will be our globals. Okay. So how do I do this? I wrote down how I did this. Okay, so this is, yeah, so 2 times db plus 1. So this is going in 2 directions. I think we need 3. Okay, let's actually think about this for a second. Let me go to where I make the offset table. How do I iterate it? Yeah, this is one of these things where like translating this to 3D isn't exactly like super intuitive. I think that we do need it. I think that we do. Let him cook. Okay, so I don't really know if we... It's hard for me to exactly think through this. because we allocate different rows, right? So it's not just one table, but based on how we're iterating it, kind of makes sense. Yeah. All right. Anyway, so this MA value is derived from DD minus sigma. And this MA value needs to actually also be a thing here. And we will just like... that's just going to be another global for now while I'm trying to figure this out. Did I do this in the wrong file? Oh. No, I just copied it wrong. Okay. So that's the row size, and then we'll do MA equals sigma minus DD. No, it's DD minus sigma. And that's why the DD, I think, always has to be greater than sigma. Okay, so now we have to loop all the axes. I think it's that. Okay. Okay, so I need to fill it with these inclusive values. Right, so I need to also allocate this. This is why the offset table should be a struct. The offset table should be a struct. It really should. I'm just kind of too fucking lazy to do that. Okay, let's make a struct. There's a reason I made this a struct before. So I have the tendency to not, like, when I look at old code that I did, it's like, oh, he didn't know what he was fucking doing. I can do this without it. And it's like, no, you can't, idiots. I don't know why you need them separately, but apparently you do need them separately for whatever reason. I don't really remember. It depends on how we use them later, but we do use them in a peculiar way later. So, you know what? I just said the whole thing about, like, trusting that I know what I'm doing. So I'm just going to trust that I know what I'm doing. And that's that. I don't know, like a little bit of a constructor here would be kind of nice. You know, you pop the sigma, you pop the DD in, you pop the MA in, and then it fucking allocates this shit for you. That would be kind of cool, huh? Do I actually want to do that? That's a good question. Yeah, fuck C++, bro. That shit is stupid. Okay, let's just get rid of this. Now we just want. We're gonna have to move that above. Don't call it table, you fucking idiot. We're gonna call it off table. What else do I need in here? I think that's it. We can derive. Yeah, let's just leave the. Let's leave the row size in here so we don't have to calculate it later. How about that? How about that? How about that indeed? Okay. That's done now. So now let's just take it in here. Why? Alright, peace out. Peace out, Max. Huh. Why is this not doing the thing? Okay. I think, IntelliSense is mad at me somehow. So, where is it? No, not any of that, bro. What? Oh. Yeah, that's very true, man. That's so true. Okay. I'm done. We're chilling. We're chilling. Okay, so what did I say we were doing here? Fill 3 arrays with DD to Huh? Oh, right. We also have to calc this, so what am I doing? This is row size, by the way. Also, I don't have to calc this. Okay, Malik. Nice. Nice. Okay. So apparently, I need to do Z. What's the what? Oh, I just set the values in it. Oh, okay. I apparently just do this. We have to make sure that we're looping everything in the same situation, though. Okay, so basically what this is doing is it's just priming our table for later, because we're gonna need these offsets specifically. It's kind of like a kernel thing, not Linux kernel, just like, you know, kernel, you know what I mean? Yeah, you know what I mean. We're just gonna do all of this, and we'll make sure to 0 it when we create it. So. Okay. Let us, yeah. So I'm just gonna do like when we initialize everything. I'm just gonna straight up do off table.x equals 9. And doing this pattern means that, of course, I need to just undo what the fuck I just did. Just classic, the classic, you know. Just making sure that we don't segfault because of my dumbass. Okay, sick. The clean code kids are loving it right now. Okay, we've set up the offset table, we've set up the pause array. We are finally ready to actually start coding. Okay, so when we get done with a section, let's just move it above the shit up here, you know? Okay. Okay, more importantly though, something that we also need to do is we need to actually create the H array, because we don't have that now, and that's kind of necessary. I'm wondering if I had H as a, was H a, I think it was FFTW complex. I don't know if that's necessary, but it was, I think. Yeah. H was, oh no. No. No, H was just a float. So we can do that as well. So this is going to be similar to these buffers. It's just going to be float pointer H, and it's just that actually. This is, we just have to allocate it to the size of the grid. So we can do that really easily during our setup. It didn't render for whatever reason. I don't care. Laugh at me all you want. Yeah, here I allocate everything. I'm just gonna allocate H. Okay. Alright, peace out, Robert. Okay, so we just allocate it once and then forget about it. The thing that we need to do, though, is when we are actually... I think when we do this, I think it's important for us to... H is the sum of all of it across all of the growth. So... I think we just do H there. Let's also make it a global. Okay. So I can just do this H, K, I, 0, and we can just add a S here. No, it's not HI 0. It's just I. I think it's plus equals S, because we're never doing more than one kernel a channel. So, yeah. Okay, there we go. Now we never empty it out though, which is necessary, and so we have to memset H 0. Okay, there we go. I have to mem set it at the beginning there, and that's that. Okay, so now that that's set up, we can actually like focus now because h is now squared away. Okay. At least I'm fairly sure that that's what h is. So now to go to the first one. The first one is the Sobel-Convolve sum, which only differs from the Sobel-Convolve by the fact that we are summing beforehand everything up. And we're summing everything beforehand by the current channel value, and that's why it's not the whole thing. Wait, but I guess we're summing, right? And so h is the regular growth sum, and then this is the sum after we normalize it. Okay. Yeah, it sucks that we have to do this multiple times. It feels like so unnecessary, but I guess it is necessary. Okay, so let's put these in here. So that's we're putting now the kernels into the thing. So that's the pattern, and these will do the thing. Yeah, they're gonna do the thing. God, that was so painful to get these kernels. The world did not want to see us implement this today. Okay. This is also going to be the same also within the Sobel-Convolve not sum. In fact, let's just put this outside here because there's no point in it being locked inside. Okay. We have to sum. So we have to sum. We must sum. We have to also sum. Okay, we have summed. We could also sum this beforehand. Instead of like doing this here. That is kind of true. I mean, you kind of wonder if it would be better, yeah? You would just like sum here. instead of looping again. I think it's kind of a whatever thing though. We can sum before this. We can. So what are we looping here? We do loop, don't we? We loop x, y, and z, and then the dx, dy, and dz through the Sobel kernel, and then we convolve the sum buffer by multiplying it times that. Wait, the sum buffer, oh, this is not a thing here, actually. Oh, shit. Oh shit. Okay. That's actually... Okay, so that means that it would be a lot faster for us to actually do this. So that's what we're gonna do. That is what we're gonna do. Yeah, so we will just add all the way back here. We also have to mem set it once again, but whatever. So we're preemptively summing, because if we don't, then it's going to be really inefficient. And in fact, it was really inefficient, and I had it that way later. So there you go. Already improving. And we're going to need to cut corners as much as possible since this is in fucking 3D. So now we don't even need this to sum here, and we can just loop through and go straight to convolution. Of course, we're gonna loop x always, x less than the grid width. I wish that there probably is a way to select the entire line. That would be like really neat most of the time. Also this, the helix thing to go backwards would also be like fucking really sick, bro. But, you know, you can't always get what you want. You can't always get what you want. Yeah, today was a sucky day in terms of progress, so I'm gonna bash my head against the wall until this works. Fuck it. Okay, so now we need to go. I probably shouldn't have had that coffee. Another sip of that coffee. It's been sitting out for a very long time. I'm still alive. Yeah, I'm still alive. I'm still alive. This is going to be -1, actually. Yeah. So this is where we're gonna convolve the kernel. And of course it's this dimension, so that's why we're doing 3. Okay. Okay. Okay, so how the fuck do I do this? What am I doing again? Right, so it's the sum buffer. Inseparable directions. The fuck did I mean by that? Did I only finish the smoothie right now? Yeah. Got a problem with it? Just fucking with you. Okay, so yeah, so we get, okay, got it. So we're getting this, okay. Okay, this is okay. So separable. What I meant by the separable dimensions is that we have this. Would you be able to guess how many lines I still need to write? If I'm doing if I'm doing all of this, the flow linear shit. After I do this, it's basically just this again with the Sobel convolve without the sum. And then it's oh wait, no, we just Sobel convolve like this, so it's not even that. Then it's this, then it's this, and then it's this. The reintegration step is probably like 400 lines of code. So over here it's like probably like another 400 lines. So, well, maybe not 400 or like 200. So probably like 600 lines. I love people who do niche programming shit. Thanks. Thank you. I appreciate that. So let's just get the index. I know that we did this in a weird way, but I'm just kind of like brute forcing this shit right now because I feel like I streamed today and I actually everything I did failed. So it's like this is I need to actually do some fucking shit today, you know. Because we like tried multi-threading FFTW, we tried averaging normals better, we tried all this shit, none of it worked. I actually like have made zero progress today, so I'm just gonna sit here and I'm just gonna make something work, like no matter what it takes. What am I doing? Okay, so we're summing into sum x. So sum x equals that sx kernel indexed by, right. So it's not actually dx. This is something that I was confused about. You would think dx, but it's actually dx plus 1 because of it's starting at -1, right? When we're in array space, it's going to be +1. So these are 3 by 3. So it's this. Yeah, I think that should. Oh yeah, we have to multiply times sum index by the index. Yeah, I know what I'm doing. Now you just have to do sy and xc. This doesn't look that complicated because it's all wonderfully abstracted away. Okay. Alrighty. Excellent. Okay, so this isn't Sobel convolve sum. This is actually Sobel convolve. And the cool thing is that we can actually take in, and then this becomes that, and we'll just call it on sum later. Yeah. So what do this, right, so this goes into an array called nabla A and nabla U, basically. So this is going to need to have the array that it goes into, right, and it's a float pointer. Yeah, Right. Yeah, so this is the annoying thing, is a float. It's a float pointer, but I don't want to go pointer. It's, yeah, so it's a, what's the syntax for this shit? I need to do this, is it like, what, I think it's that. I think that's the syntax, I think. I always forget how to do that shit. So we need to make those buffers. I don't think that that's it. I think it's this. Yeah, right. That's how you write that. Okay. I'm just going to make these globals just for now. Just so that we don't have to worry about anything right now. Because if I worry about something right now, then things are going to go badly, I think. I think Nabla U has to be like this, but I don't remember what the extra dimension is. Okay, apparently I'm stupid because I just looked at my other code and then I realized that I did this fucking wrong, and it's actually I'm supposed to do this. Yeah, I don't know why I didn't just do that. It's not intuitive because you have to do this shit. I always forget, man. Okay. So there's that. So this is this is actually, so we just add, and then the thing is, so this is the part, right, where we go the nabla index by this index, right? Okay. And so this is just the sum x, right? So we're putting this into the different dimensions of the nabla, and then later we will iterate through them properly. Okay, so we're going to call that on the array and then call that on the other nabla. Now, what was the other? Yeah, nabla u is like fucked for some reason. I can't remember why nabla u has 3 dimensions to it. It's very confusing looking at my code for it. Because I do it the same way. I'm just gonna pretend like it's fine. I'm gonna pretend like it's fine. Whatever. We're gonna pretend that it's fine. Thoughts on eating raw liver? Do you think I'm like a Hannibal Lecter or something? I don't have any problem with it. I think that's cool. It's kind of like you know, it's a crazy cold open though. Thoughts on eating raw liver. You know what I'm realizing? I'm realizing that our SZ kernel is backwards, I think. Possibly. According to this website that we got the other kernels from, it's actually, I think it's backwards. Which is simple enough to switch the... But on Wikipedia it says the opposite, but on this diagram I'm looking at it says this way, so... If this is backwards, then all of our kernels are backwards because they're all based off of this diagram. Okay, so before we go further here, I want to perform the Sobel convolution properly. So when we do update, we call update Conway, right? This is the main update function, right? We aren't just going to call that function now. So we have to figure out where we call update, the update at. Okay, so we call update Conway. So right now I'm just trying to show, like think about like what's happening here, right? So these are old updates. So now we have to so this is going to be, we have to put this in the header, but sorry if I'm not, yeah. Right, so our array that we're doing first is the sum. And this is going to be nabla A. And then we want to Sobel convolve with H or K. I can't remember what I called it. And nabla U. Yeah, so I did call it H. Did I ever allocate these? I don't think I did. No, I didn't. That's not the way to allocate that, is it? Maybe it is. Maybe you can do that. I don't think it is. But we're just gonna pretend for a second that it is. It might, no, it can't be that. It cannot be that. It cannot be that, brother. Or maybe it's, I don't fucking know, man. If it's some shit like this, dude, I'm gonna be fucking so pissed. Is that it? I think it might be, dude. Okay, what? We're thinking way too fucking hard about this shit. Okay, calm the fuck down, man. Okay. Okay. Okay, so there we go. That's the first two things done. Okay. That's the easiest part. That's the easy part. That's just like convolution, just two convolutions. It's the easiest part. Okay, so this is up here. That's what we just did. Okay. Look, we only have a little bit left. So it's not. It's like this is going to. This I didn't even write about because it's so cursed. Okay. So this is going to be the compute. Is this compute mu or compute f? Which one am I doing first? I think this is compute f. Yeah, I think that it's f first that we need to compute. It's f and then mu. Yeah. Yeah, because mu you use f. Okay. Okay, so what is f? Well, f is another array that is the same exact dimensions as nabla u and nabla a. They're the exact same dimensions. I can't remember, is mu another array? No, we should definitely call this like this. Is mu another array? No, it isn't. No, it isn't. Mu isn't even mu. It's just mu goes into f, or at least in my implementation, because there's no need for another array. Right? This is literally, you already have so many fucking arrays in this that it's like, yeah. There is a ridiculous amount of data that's transformation that happens during this. It's fucking crazy. Okay, so f is the last part. So okay, so I wrote down here. Okay, so I need to actually loop first because that depends on the thing. So we're just going to loop once again through the entire thing. Okay. Right, so it's divided by channels. Loop through channels and cells. Okay. We will wrap this completely because just for cleanliness purposes. Okay, so that, and then the index. Do I need the index for something else? No. Yes, I do. I do need the index. Oh, you know what else I'm realizing? This is wrong. And that means the other thing is wrong up here. Oops. Good thing I noticed that. Else we would have been really confused later. Okay, so we put that to the power of 2, and then clamp 0 to 1. I'm pretty sure that that's what my clipping function does. Like when I was reading back earlier. This, yeah. Okay, good. I'm just making sure because I don't want to. Okay, so we're just multiplying this times itself, and then we will clamp this 0, 1. Okay, now what else do I need to do here? So f, x, y, and z is right. Okay. I'm now remembering why this was so confusing back then. Okay, so we have to do the formula. nabla u. Okay, so basically what's happening here, if I can talk about the math, the nabla u times 1 minus the alpha minus nabla a times the alpha, it's basically getting like a delta, you can think of this, for the current step, right? We are taking the growth after everything versus the raw growth and versus the sum of the raw growth, and then we're just basically trying to figure out where our mass is moving, basically. So that's what's happening here. X times 1 minus alpha minus nabla a index. And we need to do that for each dimension. I believe so. I believe that this is what's going on here. Yeah. That is what's going on there. I am really interested, though, into, like, why this, if this H thing is correct, what H versus the other one signifies. H versus the raw sum. I don't really remember the significance of it. But yeah, thinking about it, it's kind of right, because we have the H versus the sum, and we deal with them totally differently, but like it's not in an intuitive way. Like this is adding the raw unnormalized growth, maybe this isn't supposed to be this. Maybe this is supposed to be Now, let me see how I deal with H. How do I deal with H? Huh. I don't see where I... Oh. I think that this is after. I think that this is after. I think it's just because I... Huh, maybe not. Huh. I'm looking back at my old implementation, and I'm realizing that I I don't divide by the number of channel, by the kernel count. I don't divide by the kernel count in my old implementation. Okay, we have a billion errors. Okay, so it was meant to be for this. Maybe you can do this? Flip 3-pointer? I always forget, and then I'm sorely reminded that I'm dumb every time. Oh, well, now that's just me being stupid. Okay, well, like, give me a fucking break here. Is it illegal indirection? I consistently forget how to do this. How do I do this? What's the syntax, bro? Oh, okay, so it's yeah, but how do I cast the pointer is the problem. Like, I can do that. Like, that's completely fine. But how do I cast this in that case? God, I wish I didn't have to cast the fucking pointers. It's like the stupidest thing. I don't understand why that has to be a thing. But, whatever. I am not... I should probably just make it vec3, to be honest. It's like the same thing as being vec3, actually. So I'm not sure why. Yeah, this isn't going to be allowed either, to happen either. Okay, to be honest, I'm just gonna keep it a buck with you, man. I just don't give enough of a fuck, man, right now. I don't care. They're just gonna be vec3s. They're just gonna be vec3s. There's no reason that they shouldn't be vec3s anyway, so it's... I don't care. And now it's gonna be mad at me because, oh my god, now I have to change all this shit. If I regret it later, then it's whatever. But it's also gonna be mad because I write into it up here. Yeah, that's fine. Holy shit. Jesus Christ, man. What is the problem? What did I do? I must have like missed a semicolon or something for it to be like that. Oh, it's because I this is before that. That's why. Okay, it still is fucking pissed for some reason. Because of the function signature. Okay, it's still pissed because of the function. Oh, because of the header. Okay. What? Subscript requires a rare. What? What are you talking about? What are you fucking talking about? Oh. Oh, wait a second. Oh, I need to actually do this. Wrap all of them like this. So that it can be 3 by 3 by 3. I hope that guy that was crazy drunk is alright. That guy was fucking smashed, man. That was crazy. That was fucking nuts. That guy was geeked, man. Okay. Yeah, give me the errors, not the fucking warnings, bro. Wait, what? What is the problem? Z, undeclared identifier. Oh. Four errors. Too many initializers. One, two, three. What? Too many initializers. What? Did I miss a? No, I didn't. I did not. Okay, it just wanted me to say it. All I wanted to do was check how things look with not dividing the kernel size. That looks cool. This is cool. This is sick. Once again, we aren't in release mode, so that's why there's a lot of lag. But this is with the full... This is with everything that we've done now implemented. This is with everything. This is doing all of the convolution, right? I think so. Or is it not? It might not be. Yeah, it's not. Oh no, it's not in this file, bro. It's in this file. Yeah. Oh no, it is. It is. Okay. So that makes me feel a little bit better. We should really do the release just to see what it actually looks like. The problem is that inside of here, this has different. It needs this lib file, and it needs. I think. Where is this? That has that, so it's fine. Okay, so let's try compiling this now. Okay, it works. Yeah, it's not even that slow. Then again, we haven't actually done the reintegration yet, but how do you stay focused on one project at a time? Do you have a lot of projects you want to do after this one? That's the thing, like, for me, I'll get like obsessed with something for a while, and then I'll bring it to a point where it doesn't really make me happy anymore, and then I'll do something else. Is this a game? Nah. It's more like a cellular simulation that we're working on. Yeah, it definitely is slower after you do the Sobol convolution, but yeah. Anyway, so that I just wanted to see how slow it is, because we're doing 3D Sobel convolution, which is like incredibly expensive. Like insanely expensive doing this stuff. So as long as we are still okay now, I'm like very happy. I think that this is all we need to do to compute the F array. Yeah, so it is strange, the fact that we are convolving both the sum of all of the channels, and then the H, which is the sum across all channels anyway. It is very strange. Or wait, is H... Oh wait, H is per channel. Oh shit. That's why I was confused. Oh shit. Nabla U is per channel. That's what I was... Okay, that's what was confusing me. Okay, well, that's that makes this a bit more okay, so we did this wrong. So this is that, and then okay, so now we need okay, so yeah, it's actually shit. It's actually this. You can take a seat and watch. Yeah, yeah. Feel free. Nice to meet you. For simplicity's sake, we can make it max channels. It is really. It is like a, but that does mean that all the memory stays contiguous and we don't have to do a bunch of other like pointer bullshit. So I think it's just better to do it this way, and so that's the way I'm gonna do it, at least for now. And so I'm gonna need to go to where we allocate that and fix it. Okay. So we're just going to go to max channels here, and that's going to be Nabla U. Yeah. And we can get rid of that then. Okay. So now we need to write a second Sobel convolution routine. I was trying to wonder, trying to piece together in my mind why H is different from the actual sum, and H is different from the sum because H actually is per channel, while the sum is summed across all channels. So yeah. So that means sum also needs to be max channels, or H needs to be all max channels. So that's why I was confused. I read my own code wrong when I was doing that. So that is what it is. Yeah, so that is still afloat, and that's fine. We need to go here, and we need to put this to max channels. And I did go here, and I did that right. Okay, yeah. So, importantly, we have to actually go to where we actually sum into H here, and then this needs to be per channel, right? So that's C, right? Right, and so we just add into H for that channel. And that's why I was wondering earlier about, like, oh, I thought that Nabla U had an additional dimension. It does have an additional dimension, and that additional dimension is channel. And so this is actually wrapped in a for loop for per channel. Yeah, I should always trust my gut when it comes to these things. Like, I knew it in the back of my brain that it was wrong, but yeah. So, I think it's exactly the same thing. We just, of course, are going to index into this based on channel. Yeah. And that means that this is also as per channel thing. Yeah. So yeah, this becomes a lot more obviously expensive now. You have to do it per channel. I'm not familiar with this community. Know your project. Repetitive multiplications. It would be more efficient and readable to save it onto the stack. I'm not sure what you mean. These for indexing, you mean? If you're referring to these, they all get optimized away by the compiler. Very simply, yeah. This is all optimized away by the compiler, yeah. Yeah, I think that's it. Okay. So let's put that there. At least as far as I know, yeah. The reason I tend to do this way when I have to index things is because if these variables ever change down the line, it would be really hard to, you know, deal with updating a quite large. Yeah, I mean, they're compilers are pretty amazing things. You'd be surprised. Okay, I think I'm going to put this into here. Oh no, it's in here actually. To test the. Yeah, let's see. Oh. Oh, when I'm computing F, yeah. This is why this goes per channel, is because you do this. I wonder if I think F is also per channel. But for now, we won't care. And what's the problem? Oh, wait. Oh, I just did this. That's why. Yeah. Oh yeah, I didn't do this. Okay, and finally we are missing this parenthesis. Okay, how slow are we now? Okay, well, we seg faults. Oh. Yeah, we have to loop through all of the channels and mem set this at the beginning. They've been me when I try to do an optimization beyond its own optimized scope. Yeah, I mean, people have yelled at me plenty of times for pre-computing things, optimizing things like that, when often it's just faster to let the compiler do its own thing. What? What? Hold on. Do I allocate this? I may not allocate this properly. I do allocate F and A. Bro, when I started coding, when I was like 16, And now I'm like 25. Okay, I think I'm just going to try and comment this function out, and then let's see if we can just go with the sum. Okay, so it definitely is something with h that's bad. I mean, it has to be here, right? Okay. So you're telling me we segfault but not here. Okay, now it doesn't want to segfault. Wait, what? There was no problem? No? Okay, well I must have fixed the bug and didn't compile the new one. Okay, so here I wanted to test out how fast we are. Okay, we seem to be fairly fast still. It's definitely slower. Okay, I'm happy with it. Okay. Okay, so let's make sure that F, does F need to be, F does need to be per channel. Yeah, that's what I just realized in my head. I forget how, now I'm remembering just how reliant on channels this all was, and how frustrating that is because of how the scaling is like exponential with the complexity of the whole thing. Okay, so now we have to allocate F in the channel thing. Yeah. Okay, so now the question is, and you can just hit, yeah, I'll make a note of that. Yeah, so the novel A is just that, and we are just, yeah, initializing straight into it. Okay, that's cool. Okay. Okay, that should be done, hopefully. Okay, let's see how fast we are. Okay, we seem to be okay. Yeah, it seems to be very similar. Okay. What my project is, I'm translating a 2D cellular automata into 3D space. The automata is named Lenia, and right now I'm working on the mass reintegration for the flow. Okay. I think I have to do. What did I write here? dx dy f times time step clamp. I know I'm using f here, but like, what did I write? What does that even mean? Oh, I see what that means. Oh, I'm using f. Okay, I use f as an offset. Okay, so you can just do this. Okay, so yeah, and then I can clamp like this. And of course we're gonna have the z as well. So off table dot ma. All right. Yeah, so this f is going to be f indexed by the channel I dot x. I'm sort of a little bit old, 20 years old, maybe one day. I'll create my chess engine or physics engine. Yeah, man. Just go for it. You know, don't wait for anything. Just do it. Add D to pause array. Okay, so I think what I did was there's a pause array, but I don't remember what is. I think it's that or it's this. I can't remember. We're trying to offset ourselves. Yeah, it is that. It is that. Yeah. Okay, got it. So this is also has this as well. And I think that this is just, you just add, just add this straight onto, I think that this is just goes straight onto F. And so this is FC I dot X. Is it just that? I think that, okay, so here's a different, so there's different border types, right? And so that's why this is like a separable step. But for now, I'm not even going to implement that. And so you just end up doing, yeah, it's just literally this. It's nothing complicated, but there's a border wall clipping. I'll just do that later. But for now, let's just make it super clean and, you know, readable for now. Okay, so that's mu done. And that's the last easy part that there is in this. And then it's reintegration step, which is the part that I didn't fucking write anything about because it was because it's complicated. So we have to figure this out. Okay, so let's read it. Okay. Yeah, this part is the confusing part. I think I was also doing this in parallel because I have different allocations for CNUM. Candidate CNUM. What is CNUM? Is that channel num? Oh, I think it is per channel. Okay, so we need an FFTW complex pointer. Oh, fuck. And then MUR. And then we need a loop through the DD. Okay, so let's write down everything that I need to do here. So I need to do the sigma squaring, which is it's the classic. It's that, and then I need to pre-allocate. I think, do I actually need this to be FFTW complex, or can I just do this float? I don't think I do. Yeah, I don't need it. So I can just have that as float. Float, no. Yeah, float, float array for each channel to roll. Yeah, I have to compute what is essentially a roll, which is done in machine learning libraries. But I have to do it by hand, which is, this is like the hard part. The reason why this is so complicated is because I wrote this. I'm looking at my other code base on my other screen. I wrote this in parallel with OMP, so that's why it's like so confusing. So we also need allocate MUR, which equals same size as F, I think. In fact, we could probably use F for it. I'm not really sure. Maybe I can actually, since DPMU happens there. Yeah, I remember why this is complicated. Yeah. Yeah, I think I could actually use F for MUR, to be honest. Yeah. I don't see any reason not to, since it's the same exact dimensions. So, okay, I'm gonna write out how to perform a roll, okay, because that's the main thing that we have to do. The roll is for each channel. We have to loop over each dimension, and the formula for the compute dy, or delta, right, which is, what is S? I think sy is max. Okay. Oh wait, this is so confusing. Okay, so that's why this is confusing. Roll over the DD bounds, which are the 2 times DD plus 1, right? To the power of 2, right? So we have to roll over the DD bounds. So this is going to be x plus dy DD location, right? That is, Oh, this is where we use the offset table. Okay, so this is off table index by the DD location. How do I handle backache? I from carrying the world on my shoulders. Just kidding. I do it. I don't know. I don't really deal with it, to be honest. Okay. And then plus max, right? Yeah, that's plus max. Or no, it's not plus max. It's minus dx. And then this is the modulus with yeah, this, when I figured out this formula was max. Okay, so that's the delta. That is the formula for the delta, and we have to do that for x, y, and z. Okay, so then at the end of that, right, we are setting to AR is going to equal cells, while that MUR we were talking about, which we will use as F, is going to equal MU, which we calculated earlier. But we put it into F. Okay, so we can't use. Okay, so this is no. So this is that, because we already used F to be, yeah. So we need another array. Then. God, that sucks. So all of these have channels. Every single one of these has to have a channel. So that's the reason why. Okay. Makes a lot of sense. What am I building? Yeah, it's on Windows XP. I have a computer with Windows XP. It's a cellular simulation in 3D. It's a 2D simulation, but I've been trying to make it 3D. So, what I'm doing now is I'm trying to create some complicated mass reintegration stuff that's kind of like physics, but complicated. I do have a real computer with Windows XP, yeah. I do. I have a capture card. That's how I stream. So our destination is not our destination is not the input. We are rolling them. So basically, I think it's like it's minus the dx plus sy. I think it's basically like a mirror is kind of what's happening. I think it's a mirror. Is it connected to the internet? No, it's not. Windows XP is my childhood too. Yeah, it really is. Some of my favorite games were on it. So this is dy times dy delta index, and then this one is going to be the okay, there we go. So that's how you compute a loop, a roll. Okay, so that's that. So that's the roll, and then we compute dpmu. Okay, this is also complicated. Let's just focus in on this and then do this first, because yeah, let's just do this first and then we'll get into that, because that's going to be a whole other ball game. After we compute DPMU, then we just loop through all of the channels, loop through all of the cells, and then do some math in there. And then at the end we just put it into a new grid. We just put it into the new grid. Okay. Windows XP was so I would comply more with. I don't comply with their shenanigans at all. But Windows XP was the last Windows where you didn't have to, well, I mean, maybe Vista. I can't really remember, to be honest. But now you have to, sell your data to them to, to log into the goddamn thing. So this is what we're talking about down here. So this is going to be and the sigma is our off-table sigma that we did earlier. Swigma. This formula and this code that I'm doing right now is based on the Flowlenia code, and you can get it's this Python thing, but it took me a long time to decode it for sure. But yeah. Okay, so we need AR. We need an AR. And I'm pretty sure it can just be float. AR. Yeah, so hold on. AR equals cells. So what is A? I have this variable A over here. That's, oh, A is that. Okay. Got it. A is that. Okay. Got it. So that's just the thing. This honestly could probably just be the grids itself. Yeah, this can honestly be. Yeah, but this is cells. Oh, so you need a secondary buffer. Oh, that's why. Because you need to transform cells into here. But of course you also need cells to stay in place so that you can keep on transforming. Okay, so in that case I will need another array called AR. And it's going to be the same exact thing as cells. Does it need to be for each channel? It does need to be for each channel. That's cursed. We do have back. We do have back that we could use. We could use back. The tricky thing with using back is that we then have to memset it every time, and I don't want to memset it. The distros win Vista, and above all is Win XP at the core. Wrappers are all just duct tape and makeup. Oh yeah. I haven't taken a look at any of those. Maybe I should try. It was really cool when I got this old computer out though, because I was like, man, this is so sick that I can, do this old programming stuff on it. Yeah, I don't think that I can get away with using back though, because back needs to be the current step so that it can feed into the thing. How do I do this in the least complicated way? Yeah, so cells back and cells change places, and so back but maybe back is always going to equal cells. Okay, so let's use back. So let's just make a note here that AR will be back, but can be a different array later. Okay. So now that we are going to use back, this all becomes, so what did I just say? We cannot reuse F now. So we need MUR, that's the problem. Okay, so let's make that MUR array. Well, I'm certainly impressed that they somehow broke a button. I'm aware that the start button is probably more complicated under the hood, but still, impressive result. Really? Did they break it? I think that, yeah, so this is the same dimensions as F. So I'm just going to put this also as a thing here, and we will play ball. Okay. Okay. Yeah. Yeah. Man, I love Windows XP. I don't know. I like old programming. New programming does not really excite me, to be honest. This is going to be, yeah, this is 2 times off table dot dd plus 1 times. Oh yeah, I already have this cached. This part I do have cached. Dot row size. Okay. So what now? We are rolling over the bounds now. We've allocated mirror. We also need a mem set it technically. Do I have to loop all the channels here? I do, right? I don't. I guess that happens. Yeah, that happens on the inside. Okay, got it. Okay, so all we have to do is call roll here. So what's going to happen in here is that we have to loop through all the channels. So we may as well, I wanna mem set it to 0. Because you need to, I think. Maybe not actually. I think we're guaranteed to. No, we're guaranteed to. We don't have to mem set it. We don't have to mem set it. Nah, yeah. Let's try to avoid that as much as possible because this is like already so expensive. What we're doing, we do not want to mem set anything. Okay, so loop over each dimension and then compute the delta, right? So we're gonna do okay. Okay, so now we need to, oh, but this isn't efficient, actually. This is not efficient. We need to actually nest this because of reasons. Because to save some operations, we need to do the offset calculations on each layer. So, okay. So here we need to once again, this was the formula we had, which was x minus dx plus the width modulus with the width. And the dx we have to take in as an argument. Okay. So we need to do that at each layer, of course, so that we can get the index. Okay. Okay, so the formula for this is the destination is that dx, right? No, the destination is the regular. Oh yeah, that makes sense. That makes sense. That makes totally sense. And then we just do the exact same thing with the source, but for the delta. Actually, yeah, this can't be. This has to be Rx. Oh, I can't see that person's comments. I think it's because I'm only in top chat. Oh yeah, I'm only in top chat. I'm sorry. Why am I not using Vim? Oh, I'm not using Vim because I'm on Windows XP. That's why. I use Helix on my main machine. Yeah, I always forget to switch off of top chat. So yeah, so we're rolling into MUR and AR, right? And so we're gonna go into back, index by channels, index by this SRC. This is destination. 0 equals the cells all right man, does that work? Interesting fellow. Well then, so, I'm going to be rolling into mirror, right? So mirror from, is this F? Yeah, I'm pretty sure this goes from F. Yeah. I was talking to that guy and gaining amusement. Yeah, I just don't want anybody to join the stream and like, you know, be like, you know, just like weirded out by it, I guess. I don't know. Very odd. Okay, so I think that that's it. And then this is just wait, but how do I derive dx, dy, and zz from the thing? Wait, do I have to? Oh, right, I forgot about that. Okay, I forgot a step. Because I have to index into the off table. The x, that's what this is for. I just had made a sarcastic version of there. Yeah, I don't know why some people there's some people that like came onto the streams that have been doing the streams and are just like very I don't know, against me using old technology or whatever. Like, why am I not using this? Why am I not using that? I thought that people just like think retro stuff is shit, is sick anyway. You know, like I didn't understand that it was such like a. It's so weird for people. I just think it's cool. Like I don't. Is it weird that I think it's cool? I don't know. I don't know. So here's where we go through the channels, and yeah, so we just have to do this part and then DPMU. And the DPMU is literally just all it is just putting some convolution around the border onto MUR. You use a text editor and you love it. Yeah, exactly. I've used like all types of text editors and IDEs and stuff, and honestly, like at different points in my life, right? Like I really like that stuff. Like, you know, when I started in NetBeans, and then I moved on to like Visual Studio, and then I like ended up doing Vim and then Helix and stuff. Like I don't know. I think it's just like once you start coding for a long time, it's just like you know, normal, I guess, to use different things over time. I think everybody has like had, you know, different things that they end up doing over time. I say compute every time. DPMU. Alright, so let's so this is dependent on border again. Border torus, border wall, etc. I'm not really going to implement that today. Yeah, it's exploration, exactly. I'm just gonna say if torus other thing here. There's another thing here. But otherwise, this is very simple. If it's not the torus border, all I need to do is loop over everything and just subtract the pos array from it. That's literally it. And take the absolute value. I personally have just used VS Code really because I haven't felt the need. Yeah, I mean that's completely chill, you know. Like I've definitely used VS Code as well too. It's completely yeah. That's the problem I have with VS Code as well. Is it just like gets super laggy when you have a big project. Like some files just don't open well. Yo, I'm still streaming. Yeah. Even nowadays I switch a lot. Yeah. I've used everything, you know. I like switching it up like every few months, you know. 0 equals oh right, dot x, right, because it's vec3, and we will take the. Do I have fabsf? I do have fabsf. This is the pos array, indexed by I minus the murci. Wasted a lot of time debugging when the autosaves aren't debugging. Yeah. I like permanently. I just like do Control S, or when I'm in Helix, I do you know, WA to like save all the time. I forget what pos array is. Oh, tell me what is inside of pos array. Right, it's indexed by 3, right, so that's what that is. All this is doing is offsetting us, so... Okay, so that's that. So that's calculate DPMU, compute DPMU. All that does is it offsets the MUR array, and now's the last part of this step. So this this formula that I have here is the clip. So there's a clip value that I calculate. I don't know what this does. This last part is so confusing. I do not remember this at all. This was like a year ago I wrote this. But it's times the off table dot sigma. Oh, this is... Okay, so let me read this and try to figure out what this does. So this is 2 times the sigma, and if 2 times the sigma is less than 1, then we stay 2 times the sigma. Else it's 1. Interesting. Okay. So it's basically just capping this, or this at 1. I mean the min of it. The min of it is 1, so that makes sense. That completely makes sense to me. Okay. So we can't do that. I'm gonna do what do I want to do? I'm gonna do p less than, so this is the entire span. And this is the most expensive part of the entire thing that we have programmed. It's the final step. We are doing the final calculation, which is, okay. Right, so this is the part that it's going to be hard to, it's going to be very difficult to translate this into 3D since we are swapping y and x. We are swapping y and x, and the reason why we're swapping y and x is because it's undoing what we did all the way back. We do swap it at some point. We do swap it. Yeah, all the way back here. All the way back here. This goes into here, that goes into there, that goes into there. And so all the way at the bottom now we swap back because that triple 4 scares you. Yeah, it should scare you because it's extremely expensive. What we're about to do. Okay, so yeah, so we need a z, right? Yeah, so this is the MURCP dot x plus the sigma. And we just do that for these 3. Okay, and now's the part where you clip it. So if it's less than 0, then it's 0, or if it's... Oh, yeah, why didn't I just, this is just, you're just clamping it between 0 and clip max. Yeah, I wrote that in a very confusing way. Probably because I was confused as well when I was reading the code for it. We could also just do this inline as well. There's nothing stopping us except me. Okay. Master of iteration here. Yeah. It's kind of necessary, unfortunately. I know it's cursed, but that's why Flowlenia in its, state is only, it caps out at about 100 by 100 in a 2D grid, so there's a reason for that. Okay, so now we have our final array here, which is yeah, I think it's just we just sum it up into our final array that is also per channel. Yeah, the only reason I had this as a separate thing, I think, was because I was multi-threading it and it was necessary, but I don't think I need that anymore, and I can just sum it straight into the end, which, if I'm correct, I believe is actually grid, which is actually cells, by C, by P, right? 0 plus equals this. Back, which is what we were put into AR, instead of AR, next by C, P, 0 times that cubed, and then we're done. I think that's it. Oh, right, this is actually S2. And actually, yeah, so that's actually S2. Yeah. Okay. I think that's it. Yeah. What are N COSA and N kappa? Oh, you need to actually, you would have to mem set this. You would have to mem set it here. The question is, like, is it faster to mem set, or is it faster to just have another array? It's probably faster to just have another array, to be honest. Not to be honest, it just is faster to have another array, but there's just so many arrays. It's ridiculous. Cross operating system API, cross architecture. That's awesome. What is it used for? That sounds really complicated. Okay, I'm putting this all in the header, and we're just sending it. just sanding it. I think that's it. I think that's it. I don't think that we had this in the header, did we? Yeah, we didn't. Okay, I'm not expecting us to not cite faults here. I'm kind of expecting us to. What are the name of the? I forget. Let's just reintegration step at the bottom. Okay. So many warnings. Okay, undeclared identifier. Oh, whoops. Okay. What else? Wait, hold on a second. Wait, what? Wait, how did I do that? Oh, I'm just supposed to add. Wait, what? Okay, I'm just going to... Yeah, I think that this is... This... My own code is confusing me over there. But I think that that's just that. Okay. Okay. Well. Well, that's quite painful. I mean, yeah, I'm probably off somewhere. The two modules are part of the larger system. You write once and you should be able to run your program anywhere. Wow. That's sick. Yeah, I've had a lot of problems with that, with porting stuff, to be honest. It's always been quite painful. Yeah, well, I don't really know if I was expecting to just like get away with murder here and get and just win automatically, but you know, let's just go and take a gander at what the oh wait, I'm not actually even getting into that function. Is okay. Oh yes, I don't actually initialize the off table. Okay, well that would explain that. I don't actually call this function, which is my own stupidity. Yeah, I need to call both of these functions for everything to work. I also need to use a good sigma of like 0.4 and 0.5, I think, something like that. I think that's 0.9, I think. Okay, so let's just go down here and then for example, you make a rendering seed with a cube spinning on your desktop, and you just export it to a micro an LED matrix. That's crazy. How does it do that though? That's nuts. How is that even possible? That it's like portable. Like that. It's crazy. Okay. Went out of bounds. Okay, I would love for you to tell me. I would love for you to tell me what destination and source are. I would love for that. Oh, I'm in release and not debug. Okay, we're at 0, 0. Okay. Wait, what? We should never go out of bounds because this is the modulus here should keep us in bounds, unless I forgot that it was -1 or something. It's not -1. No, it's not. It's not -1. The window is called a panel because the actual rendering will be fully modular. It's possible that I am a... No, I mean, that's crazy. That does sound insane. It does sound insane. Do you like transform whatever, you know, like how do you figure out what you're even performing on, you know? Like, for example, it being on a computer versus it being on an LED, you know? That's crazy. That is insane. To be honest, I don't know how things work on the inside like that. These are always the same. Okay, now they aren't. Okay, but I know that it's going to go out of bounds. Um, 2304 39168. There really should be enough space inside of MUR for that amount. That should not be going out of bounds. That should not be going out of bounds. See, this doesn't even trigger it. So how do I allocate this MUR array? Do I allocate it? I do. Grid with... don't as a user, you specify everything in the actual configuration from what architecture you want to what system level it's at. Oh, I see. I see. So I guess you have to specify some things about the hardware for it to know ahead of time. That's a very useful thing, for sure. I almost wonder if don't say that we're out of memory. We're not. There's just no way. Let me see how much space is this actually? 32 by 32 by 18, I think it is. It's 18,432. So I guess that is out of bounds. We are 18. Okay, got it. So we are out of bounds. That is out of bounds. Huh. Okay. Now that's the destination. So let's straight up this. Oh, fuck. Oh, my God. Oh. Lord. What is wrong with me? Okay. Yeah, well, that makes a lot of sense now. Okay. We are extremely slow. Yeah, so we're probably doing something else wrong. Okay, well, I guess I have to read through it and make sure that I am doing everything correctly. For example, OS or metal. If it's OS, I don't know. Got it. But you deal with the actual, like, the translation, you know, of all that, based on what the hardware specifies. Nah, that's awesome. That is sick. That's crazy. That's an infinite size project, though. You know, that's never gonna finish, sort of thing, right? That is crazy. That is really nuts. Yeah, maybe we can't actually put it into cells because this feeds back into the DPMU, so you can't actually do this. You can't. You need another thing. How it does it is outside of the user developer's concern. Yeah, but that's the sick part about it. That is the sick part about it. Okay. So, let me allocate another array then, because that's the only way to actually do this. You actually, yeah, you just straight up need another one of these. I guess you could put it into like one of these, like you could put it into T technically. And just swap it after. Yeah, we can do that. Because it's also per channel. But you do have to mem set it then. Only need for concern if it doesn't support anything. They have to implement an extension. Oh, I see. I see. Yeah, I mean, that's pretty hard for you to do though. You know, to like say that you have a translation layer to the N64 is pretty crazy. I'm still working on this. I'm still working on it. Yeah, I think I'm just gonna go T. Just zero out T and then swap the pointers afterwards. No one has a life to spend. Yeah, I think everybody has a life to spend. They just want to spend it doing other dumb things. Hey, I mean, I'm no different than you, to be honest. I mean, look at what I'm doing. I did this wrong. There we go. Yeah. Oh my god. Oh my god. Oh my god. Oh my god. Okay. It is the laggiest thing I have ever experienced in my entire life. And it is all... Okay. First things first. Let's put this in release mode. Oh shit. Okay. Oh my god. Huh. I mean, I assume that you're happy programming. I'm really programmed. That went deep into mathematics. Yeah, I mean, the stuff that I do is pretty much mathematics too. It's all sort of math. Yeah, it seems like so this all the line stuff that's happening here. If I had to guess, it's that we computed the roll wrong. And so it's supposed to loop around the sides perfectly, but it's not. And so it's kind of like sticking in layers. But you see this like smooth sort of like growth that's happening? It is sort of working. There is a bug somewhere in the code for it though. Wow. Yeah, it is quite jittery. Oh my god. Wow. That's fucking sick. That's so cool. Oh man, that's cool. That's so sick. It's like, do you see how it's breathing? That's the whole point of it. Do you see this? How it's like breathing up and down? And like jiggling around? Oh, that's so fucking sick. I want to create it now, yeah. It's so worth it. I don't think anybody has done this in 3D, at least from what in terms of the mass reintegration thing. Such moments are worth it, yeah. Yeah, exactly. Oh man, yeah, there's definitely some bugs in it. Like, it's not perfect yet, but it is working. Like, you can tell that it's working. And it's still super laggy with 3 channels. Like this is with 3 channels is crazy laggy. Because it's exponentially complicated with multiple channels because everything is per channels. Oh, that's fucking so sick. Whenever I implement optimization and modularity, yeah. Oh, that's so cool. That's so cool. That's so cool. Man, I totally want like collision on it so that you could like walk around. I think that would be cool. Yeah, that is true. You do get kind of caught up in the... That's why nowadays I just try to like do code like dirty, or else I just get like stuck optimizing things for forever before I get them done. Yeah. Yeah. I can go back and like profile it and fix it later, but yeah. Or else I just like get demotivated, you know. But then again, I do have like fucking really bad ADHD with this shit. Like, you know, people when I say that I'm ADHD, people are like, "Oh, are you diagnosed?" Like, yeah, I am. Oh my god. Yeah, some of it's super temperamental, and when it gets into stuff like this is, yeah. I really want to relook at the rolling code. Just to make sure that it's working good. At least I got something done today because I was having some real difficulties earlier with things. That is me. That is me. Honestly, I don't even like, I don't know. Maybe it's just normal to me or whatever, but I don't think of it as like a bad thing having ADHD or whatever. Like it's just, you know, it's whatever. Yeah, it's not a thing. Been working on my own game engine, a chess engine. This is a trauma dump? It makes me fucking excited to wake up every day. Yeah. Well, I'm glad that you're that you found something you enjoy right now. All right. Have a good night, man. Have a good night. Have a good night. And you're welcome anytime. I wonder if this I should like walk through the code again just to make sure that I didn't. Then again, my code might also have been always wrong. God, man, yeah, it's so close to being perfect, but yeah, there's probably something else. Okay, so let's just walk through from beginning to end, just to make sure that my math is correct. Also, our Sobel convolution, I'm not really sure. I mean, once again, these tables were taken from online, right? So I have to kind of trust them, but not entirely sure. We just kind of have to trust them blindly. Yeah, man, we all go through tough times, man. It's trust me, I've fucking been through a lot of, shit in my life, but like, you just gotta try and keep doing what you enjoy. So that's the whole point, man. Yeah. So I do exactly this. I sum up, and then these just become the sums. And this NIDX is exactly that, yeah. Okay. So I do that, and then the exact same thing down here. Yeah. So I don't think that this is wrong. I don't think that this is the wrong part. If anything is the wrong part, it's the fucking part where we wrap around the thing. Alpha equals the cells over the channels times right. So yeah, I just yeah, this is squaring it and then clamping between 0 and 1. Yeah, that's absolutely correct. And then we just loop through and do this. Make sure that all of this is correct. Yep. Yep, and we do that per channel. Yep. Yeah. Okay, so all of that is guaranteed correct. Otherwise, we're under the sun, yeah. Compute mu. We're clamping between the negative MA and the MA. Yeah, for each one. Yeah, for each one times the time step. And then this is the pause array plus each one. Yeah. And then we also have a border thing here that we can try, which is clipping, which we do IX equals clamp IX plus DX between off table dot sigma and grid width minus sigma. And then this is going to be the same thing for... That's actually strange. Maybe that isn't the same sigma. I don't think that that is. GGGE. It apparently is. But this is like 0.5, so it doesn't really make sense to be 32 minus 0.5. But maybe it does. That's a huge number. But this is something that we can try for a second here. There are different border types in terms of how you... It'll be fine as long as we do not dereference it, the pointer to the sun. Yeah. Dangerously close, bro. Do not want to touch that memory. Yeah, it's probably with the roll. Like, if I had to guess, it's probably something with the roll. I'm almost wondering like if it's -1 or something like that. You know what I mean? It kind of would make sense for it to be -1. Or it could be where we calculate the off table too. It could be off there. Is this row size correct? That's a good question. Is the row size what I think it is? The row size. Oh right, the row size is. Oh right. I had to do this 3 times because it's 3 dimensions. Right. Yeah, I don't know. The off table is probably off. Triple nest the macro. Like Terry said, the command shouldn't optimize. Yeah. Maybe I should have calc'd this. Are we guaranteed to go through the whole off table? Yeah, maybe I'm indexing those wrong. Let's try calcing it. We might as well just try. Oh. Maybe I have to cube this because it's in 3D. That might have to happen. Yeah, I think whatever I changed made us have way more jiggliness going on. Yeah, what definitely is happening is that we're off by 1, and you see, like, we're just coming to the other side. You see what I'm saying? Like, that's 100% what's happening somewhere. I agree with you 100% on that. I agree with you 100% on that. I hate the fact that I can't pre-compute things because it's actually slower to not pre-compute things in some cases. Like this guy in this Discord was yelling at me because I pre-computed this modulus math in this table, and he was like, actually the compiler is just going to optimize that out for you. It's like, okay dude, like, you win, I guess. Yeah, anyway, that border clipping was 100% not a good idea. Oh wait, hold on a second. That I did that wrong. Oh wait, maybe I didn't. No, I didn't. Maybe the MA needs to be calculated differently when it's in 3D. I want to see how I make the pause array. Nip pause array. Just loop all of the. Just loop through this. Yeah. Yeah, that's exactly what I did. But maybe I should have done this the other way around. This is float, yeah. Let me try this, guys. Okay, yeah, well that's definitely not correct. That is definitely not correct. It actually makes me happy when something like that just doesn't work. Because at least I know that I was somewhat on the mark with this. Okay, so that definitely has to be cubed, I think. Yeah, if things are dying that much, then I think it has to be cubed. Sorry, I'm not watching chat. For example, you want the compiler to handle everything because it's good enough. Yeah. Yeah, I'm not smart enough to know any of that. Yeah, it's not that either. Okay, next I want to try that -1 idea on the roll. I think that's kind of the next logical step to try and get it working. Try -1. I think you're still supposed to modulus with the height, but okay, well it looks like it's not that either. What did I do? All I did was malloc that instead of calloc that. What did I do? What did I do? Okay. Okay, apparently I broke something somehow. Don't know how. Was it really calicking this? No, it wasn't. It's something else I changed. Yeah. And this isn't plus, right? No, it isn't plus. Let me make sure that t has instead of 1 is 0. That's important. Yeah, once again, I think something else that I change here is just not good. Whatever. I might not be able to figure this out tonight. I'm pretty exhausted. And all the code looks the same right now to me. It is a bummer though, because I'm like so close. Like, to be honest, I probably just need like to take a break and then come back to it, I guess. Oh hey, what's up, Kane? How are you doing? Yeah, it seems to be doing this even more now than it was before, which is annoying. Because I really didn't change much other than just like zeroing some stuff out. Of this, I changed this. That is what I changed. It's so bizarre. Yeah, none of this stuff is changing it, so. The strange thing is that it's mainly, well, no, it is the other channels as well. Yeah, sorry, I've been reading chat. Yeah, it could use some simmed instructions, yeah. It could. Oh, that's so sick though. The red is really cool. If only I could figure out the bug, whatever the bug is that's happening, then it would be very sick. It is pretty sick though. It has like so much more of an organic sort of movement to it than it did before. It's so violent sometimes, like this is just so crazy. Wow, this one's incredibly laggy. Yeah, I mean, I don't know. I don't know what the bug is. It's really hard because it's hard to know how to translate some of this math into 3D, you know? It's not easy to figure that out. Because a lot of it just like makes sense in 2D. Because it's made for 2D, you know? And this doesn't need to be cubed, right? No, I don't think so. Yeah. In fact, that just made it like a lot worse. Maybe it's got something to do with the hyperparameters themselves, though. Like, I haven't really considered that it might have to do with the sigma that we're using. Oh, Jesus Christ. Okay, well, maybe me putting the sigma down there wasn't the greatest decision. Okay. Yeah. Oh, this is like, I was supposed to do 1.2, not 0.1. It's like one of these like cloth simulations that they have nowadays, but yeah, never mind. The values we had are pretty optimal. They're what I used previously. Yeah, we also I didn't really play with the parameters themselves. Also something that we didn't do. I wonder how I'm going to do collision with it. It's not exactly going to be the easiest thing. Yeah, I have no clue. Well, whenever I reload, isn't it threaded? No, yeah, it isn't threaded. Actually, it isn't threaded. I probably should make it threaded, but yeah, it's not threaded because I'm maxed out on threads on the rest of the shit. But yeah, I should probably thread it. Yeah, it does take a while. Yeah, it's because of the Win32 painting thing. It's fucking takes so long. Yeah, it sucks. And I'm absolutely correct that this is this way, right? Like this is I'm absolutely correct about that, right? Yeah, it seems about the same. Yeah, I'm inclined to just trust myself on the math before, but probably make that possible. The review is multi-core is naive. Yeah. Yeah, it's it's hard, like in everything I've ever done when it comes to multi-threading. It's always hard to deal with, you know, any chance that that it isn't. Yeah, exactly. Yeah, it's one of these things where it's like it's kind of annoying for me because it's like I don't even know like what the correct choice is, you know. It's kind of hard to know without like actually trying it out on different hardware yourself, you know. Yeah. Yeah, that's fun stuff indeed. Yeah, hold on. So let's try something. Let's actually try something for a sec. Let me try not adding this epsilon to these. Yeah, you know what next I'm going to make, change the color, based on density. That's what I'm going to do next, but I do want this to stop doing this, whatever this is. I also think maybe it's possible that, that bug that we're experiencing might actually be just how it looks in 3D. Because I experienced a very similar thing when I did it in 2D. The XY plane is more preferable for it. For you're talking about just you're talking about like 2D versus 3D. Is that what you mean? I think it's because 3D convolution is extremely, like, it's possible that you can get it wrong very easily. The axioms of the system. Oh, you're talking about the patterns we're seeing? Where they go across that way? I'm not really sure. Like I said, it might be like a wrapping around thing. It's also like there are biases, I think, with just FFT in general, with the direction. I think it's also got to do probably with the fact that we're not inside of a cube right now. We're inside of a rectangle. So that's probably has something to do with it too. Like we can try 24 by 24 instead and try and see. Oh god, that's cursed. Oh god, that's cursed. Yeah, I don't know why it works better with more space than that. Hey, what's up, function? Hey. What am I looking at? A cellular simulation gone wrong. Interesting. Yeah, I wonder why. It might have to do with kernel sizes. Like, if we have a kernel that's too big, then it may wrap around or something with how FFT is doing things. I think that might be what's happening. Why 24 seems so bad. Now this is gonna lag a lot. Oh. Oh. Yeah, we ran out of memory. So that's what that happened. When I did 32 by 32 by 32. So can't even test that. We ran out of memory. So there's that. Let's try like 4 threads. Maybe we don't run out of memory. No. Yeah. That's kind of the problem with how we're doing things, is that it's possible that we run out of threads, run out of memory because of D3D be getting mad at us, which sucks, but that is what it is. Yeah, at 32, it seems to just work. No, it's still there. It's still there. That still is. The thing is, that's the X and the Z. Because our Y is actually the up and down. We're Y up. So. But sometimes like this, it works fine. Or not fine, but it's always across in the same direction. Yeah, it's always across in that's in the X direction, but yeah. Yeah. Well, I don't know. Maybe I don't figure it out. So, I have been live for, 9 hours. So, I am going to, I think, call it and come back to it later. It has been fun. The first 5 hours of the stream, I just could not get anything done. But yeah, yeah. I hope that that I figure out whatever it is. I wonder if I'm iterating something wrong somewhere. Maybe even earlier on in the simulation that causes those patterns or something. I don't really know. Yeah, I think that this way of taking this is correct. We could also try normalizing by kernel count again. I didn't think about that. Yeah, it still is happening. Yeah. I also wonder. Yeah, you do kind of wonder if because this one doesn't have that. wonder if that's only a property of when I generate neighbor sums. Yeah. Yeah, probably not. I mean, it's already kind of falling into that strata already, so yeah. Maybe this has to be the other way around. Doesn't this matter the way that you do it actually? Hold on a second. The order matters there. The order matters, but I did it this way anyway. I did it that way anyway. When I made it here. Yeah, we should think critically about every... No, that's no problem. That's no problem. Yeah, I'm trying to figure out. I think the conclusion I'm coming to is that I probably am iterating something in the wrong order. I think some of these things matter the order that you iterate in them in. Not these, because these are all just like doing sums. But maybe like here? No. No, here this is just looping over everything. You don't really care about it. No, yeah, this is just over everything, yeah. Yeah, here is kind of the suspicious part. Here definitely could be something. I'm not really sure though, but we should just give it a shot. Couldn't hurt to try it. from what I can think of, it shouldn't really matter here. But maybe. Yeah, this just goes through everything. Yeah, nothing else. So, I was questioning it because it might be a consequent result, or actually, yeah, I think it's an accidental bias for sure. I think it's something is getting iterated in some manner that's biasing it towards a certain direction. And it's like the smallest thing can have big consequences like that. Oh. Yeah, I think this is the exact same thing, yeah. Yeah. I may just have to look at it with fresh eyes, to be honest. I'm kind of like just like not seeing the code anymore, you know, when you get like that and you just like start just like looking at the screen, you know, you're just looking at the screen now and not the code. I'm just not even seeing the. Okay, so apparently you can't do that. No. All right. Well, thanks for hanging out. I might be back tomorrow, some other time probably. So, yeah, exactly. Taking a walk will help help me figure it out for sure. All right. Yeah, no problem. Exist here anytime. Anytime. All right. I will. I'll see you guys. See you guys soon.